ஆமா. மீட்டிங்ல இருக்கும்போது அப்படிதான் கேட்கும்.
குட்டியா கேக்குது. கம்மியா
Good morning, Professor Casey. Professor Casey.
Hello, good morning. Good morning.
Shall we start?
Nitakupigia. Hello, morning, madam.
Morning, Professor. Shall
How
we
are
start?
you?
Yeah, fine, thank you.
Yeah.
So, shall we start the session?
Yes, I'm ready.
Okay, so we'll ask start.
Sometimes it's not a new environment that we need, but a new perspective. A very good morning, everyone. I welcome you all to the second day of the virtual conference, Breakthrough and Approaches in Contemporary Scientific Research. To begin with the first session of day 2, I would like to invite Dr. Casey F. Kilulia, Senior Lecturer and Head Department of Chemistry, University of Dar es Salaam, Tanzania, on the topic Blue-Green Algae, Blooms and their Toxins as Emerging Contaminants in the Environmental Water. Before that, I request Dr. N. Aruna Devi, Assistant Professor, Department of Chemistry, to introduce the chief guest. Please, ma'am.
Education is the most powerful weapon which you can use to change the world. Good morning to the learned gathering. I deem it a great privilege to welcome you all for the second day of International Interdisciplinary Virtual Conference on Breakthroughs and Approaches in Contemporary Scientific Research. It gives me immense pleasure to welcome an eminent scientist, Dr. Casey F. Kilulia, Senior Lecturer, Analytical and Environmental Chemistry, University of Dar es Salaam, Tanzania. I would like to brief his profile. Dr. Kilulia received his BSc with Education in 1999, majoring in Chemistry and Mathematics, MSc in Chemistry in the year 2005 from University of Dar es Salaam, and PhD in Chemistry from University of Johannesburg, South Africa in the year 2012. Sir then joined postdoctoral fellowship in the year 2012 to 2013, the same university. Dr. Kilulia was employed as an assistant lecturer at UDSM in the year 2006, promoted to a lecturer position in 2012, and then senior lecturer in 2019. He has authored more than 20 scientific publications and so far. His scientific research interests are in the field of analytical chemistry, environmental chemistry, material science, and chemometrics. Sir has published and many research papers in reputed journals like African Health Sciences, Tanzania Journal of Science, and Journal of Environmental and Analytical Toxicology. And Sir is a collaborating member in the consortium of Tanzania Netherlands Energy Project, funded by NUFFIC, the year 2016 to 2019, and in Center of Excellence for Water Management, hosted by the University of Addis Ababa, Ethiopia, funded by World Bank. And Sir has participated in many different international conferences, and his research findings were published in many papers. And Sir is currently a secretary of Tanzania Chemical Society. I extend my warm welcome to the participants from various institutions. Once again, I welcome you, sir.
Thank you very much. I just have to share my slides.
Sir, you can start now, sir.
Yes, I'm starting. Yes, hello.
It is audible.
Yeah, I'm starting. I want to share my slides. Hello. Do you see my slides?
Yes, we can see it.
Okay, thank you. Okay, good morning, everybody. As I have been introduced, my name is Casey Frederick Kilulia from the University of Dar es Salaam Chemistry Department. Today, I will share with you on the blue-green algal blooms and the toxins as emerging contaminants in environmental water. This is my university, University of Dar es Salaam, and my department is just located around there in Tanzania. Freshwater is a basic ecosystem which sustains life and provides various socio-economic and ecological needs. However, its quality is in most cases is affected by pollutants and a mixture of continuous changing emerging contaminants, which are currently a major challenge. Now, the emerging contaminants currently are a major challenge because they are not given a major emphasis, or the data do not exist to determine the risks of these contaminants. So algal blooms and their toxins are one of the currently reported emerging contaminants which affect fresh water bodies. If you look at this globe map, you will see that the clean and safe water worldwide is actually a limited resource. And therefore, the concern with water is on both quantity and quality. And that's this little resource which we have. Having that quality problems, researchers from different areas are concerned with the source of pollutants or the source of causing these contaminants into the bodies. Therefore, harmful blue-green algae being one of the emerging contaminants are the serious problem at the moment, which affects the water quality and hence reducing the water quantity, which is usable actually to different applications. The occurrence of blue-green algal blooms Blue-green algae are a diverse group of photosynthetic organisms found mostly in freshwater bodies, mostly as a result of eutrophication. They occur naturally, and they are currently a worldwide problem. Over many years of this blue-green algae have not been regarded as waterborne pathogens until recently, when the US Environmental Protection Agency listed this blue-green algae on the contaminant candidate list. And that means it is an issue of public health concern. And that's why we are actually giving attention and conducting some researches in our environment and water bodies. Blue-green algae blooms are known to produce toxins, which are commonly referred to as cyanotoxins. The most well-known case of human poisoning by cyanotoxins was the poisoning of renal dialysis patients that occurred in the year 1996 in Brazil. It brought about the concern of what these poisons are. Now, the availability of nutrients in fresh water and other favorable conditions normally result into the occurrence of growth of these blue-green algal blooms. What are the sources of nutrients in fresh waters? If you can look at this photo, you will see different sources of nutrients in water, which includes fertilizers, wildlife, livestock, agriculture, municipal water, wastewater, industrial effluents, and also atmospheric deposition. These are the sources of nutrients to freshwater bodies. And once this happens, once you have those nutrients and other conditions, which we shall see later, it leads to the growth of algal blooms, which adversely affect the quality of water. And then you can see the lower photo, which shows the water body, which has been highly affected by blue-green algae. Furthermore, when they grow further, they actually make a layer on top of water. And because of that, they can't live forever. They just die. Some of the cells dies in the water. And now because of that death of the algal cells, they release a lot of toxins and other secondary metabolites into water. So for that case, leading to the death of different aquatic organisms, including fish, as you can see in this photo. So apart from the toxins being the reasons for killing the fish, but also they do cause oxygen depletion in water, change of water pH, which may not be conducive for the survival of different microorganisms in the water bodies, but also the color of water is affected, the smell of the water affected, and also the taste of water is affected. So in the process of treating this water for human consumption, still it makes the water treatment difficult because they are very stable in removing them in the process of water treatment. And for that case, it is really a serious concern. But also, apart from that, they render water not suitable place for recreational activities once they are affected. As you can see, this signboard in here indicating is a danger water body for swimming because of algal toxins. So making water not really a friendly resource to use once they are affected. So the release of toxic metabolites to aquatic environment, as I said at the beginning, it's actually due to algal cell lysis. That is the death of the algal cells. Once they die is when they release whatever compounds are contained in their cell. And in the fact of these algal bloom cells, they normally contain a lot of lipids, including the toxins, which are most dangerous. In East Africa, algal blooms were reported nearby Lake Victoria in the year 1980, which were associated with massive death of fish as being the one which is the most common indicator of their occurrence. Unfortunately, as we are speaking, the guidelines and the standards for algal toxins are yet to be established. And if there's any at the moment, it might not yet being so popular to be noted by different regulatory organs in different countries. If you look at this photo, you will see the death of lesser flamingo, which happened in Tanzania, of about 10,000 flamingos were found dead in the year of 2004. And this was reported by BBC News in July 2004. And therefore, this made a mark for the occurrence of harmful algal blooms in Tanzania, which was noted through that instance of mass fatality of lesser flamingos in saline lakes in Arusha and the Manyara regions, which is actually the northern part of Tanzania. Now, following the massive fatalities of flamingos in 3 soda lakes in Arusha and the Manyara region in Tanzania, the year 2000, 2002, and 2004, both water and the tissue of dead flamingos were analyzed for cyanotoxins, and it was confirmed that the death of these birds was actually due to the presence of algal toxins. Later on, more algal blooms were reported in different areas of Tanzania, like in Lake Babat, which is the central part of Tanzania, Lake Rukwa in the southern eastern highlands of Tanzania, Morogoro, and Lake Tanganyika, that's the western part of Tanzania. So these are the water bodies which are current in Tanzania being reported to be affected by the algal blooms. Now, because of their existence, we need to know what are the factors which may lead to the formation of these algal blooms. There are several factors, but here I've mentioned the main one, the key ones. The first one is availability of inorganic nutrients and high season water temperature. They normally grow at a relatively high temperature of about 28, 29 degrees centigrade. But also a particular pH level is favorable to the growth of these algal blooms, which is commonly between 6 and 9. They need also a good light intensity for them to grow, but also they need water which is not highly disturbed, not moving probably, or less moving water, then that is a non-moving water. In that condition, they normally grow quite well, but also in the presence of phosphorus. Even if the phosphorus, it will be in there at a less level of concentrations, it will normally trigger the growth of algal blooms. And therefore, these are the factors. If we can control them, we may, to the large extent, be able to control the formation of algal blooms, and therefore to avoid or to stop the occurrence or the contamination of water by this type of emerging contaminant being referred to as cyanotoxins. Now, because the heavy metals or the inorganic nutrients plays a big role, I'm here giving the highlight on the contribution of heavy metals on the growth of blue-green algae. The increasing usage of heavy metals and the widespread dissemination in the aquatic environment has stimulated many studies on the effects of heavy metals on the blue-green algae. And we conducted some studies on the effect of heavy metals on this growth of algae blooms in our laboratory, trying to see how can these heavy metals either contribute to the growth or probably affect the growth, and maybe it can be in a way a total cancellation if possible. So generally, heavy metals contribute to the growth of blue-green algae, and the production of high level of toxins in fresh water, but not at all range of concentrations. There are at certain concentrations, they do become toxic to the blooms themselves. So a study conducted in our laboratories, which was published in 2014, revealed the importance of iron in the growth of algal blooms. We investigated how iron affects in terms of amount, contributes or affects the growth of algal blooms. We noted that it actually contributes to the growth, but as it contributes to the growth of the blooms, it comes to a point where it also contributes to the production of different secondary metabolites in the cells of these algal blooms. So we did this research and we are using fatty acids as one of the indicators to see what happens when the concentration of iron is increased in the growth media of these algal blooms. What we noted, if you look at this one, this graph in here, we saw that the total fat acids actually had the same trend with the unsaturated fatty acids. In other words, we can say from the low concentration to about 2.2 milligram per liter of iron, actually there was an increase in the amount of fatty acids in the blue-green algae. But after that concentration, the levels of these lipids actually decreased, indicating that maybe even the growth of this blue-green algae also decreased. So the metal plays the roles in terms of either fostering the growth and the production of these secondary metabolites, including the toxins, but at a certain level will actually affect these materials, including the production of that. So at optimum concentrations of these heavy metals, there may happen the effect and the contribution to the contamination of water by these secondary metabolites from the blue-green algae. Now, surveys in different parts of the world have found that between 45% and 90% of blooms of blue-green algae produce toxins such as microcystins, which is very common. Microcystins, abbreviated as MCs, is the 7-membered heptapeptides compounds and which are mainly found in fresh water. MCs are both highly soluble and relatively stable in water, posing a worldwide health concern. So the problem of them being soluble makes it even very difficult to get rid of them from the water bodies, but also they are still stable. Being stable, it means they may just pass through all water treatment stages and possibly be obtained or be consumed through drinking water or tap water usage. So these toxins are released mainly when the cell of blue-green algae actually dies. That's what I said, the water cell releases. This is the structure of the microcystin. It's a big molecule, but having the number of polar functional groups, it is actually soluble in water, and yet it is stable, and that's why it exists. And the WHO set the threshold limit of this to 1 microgram per liter for drinking water. This was reported by Bertram in 1999. So at least that this kind of information of which we may try to check our water, the levels of microcystins in the water we're using for drinking. Currently, the study for the levels of cyanotoxins and identification of their indicators is actually going on in our research laboratory, in our research groups, that is in our laboratories. And at this presentation, I will not be in the position to share those findings because we are yet to confirm a number of issues. But we have made more studies on the existence of fatty acids, which we are trying to set a link between the levels of fatty acids and the toxins in the blue-green algae. Thus, we say, moreover, it has been revealed that the toxicity of cyanotoxins in water is enhanced by the presence of other secondary metabolites. So because of that, we embarked in a study of trying to establish a sort of biomarkers, a kind of compounds which can be easily detected, but yet be correlated to the existence of cyanotoxins, trying to avoid the complications which is actually surrounding the detection process of cyanotoxins, but also the supplies in terms of standards when it comes to toxins is a bit involving in terms of regulatory bodies. So for that case, different levels of fatty acids, for instance, particularly polyunsaturated fatty acids, for example, have been reported to contribute to the toxicity of some on other aquatic organisms. And we did the investigations on the levels of fatty acids from the algal blooms. And this is a paper which was published from that study, in where we had to investigate the effect of the growth media, the iron concentration, as I mentioned at the beginning, and the variation on cellular fatty acid decomposition. And in this study, we had to establish a number of factors and also correlations on these fatty acids and the possibility of being used as biomarkers for studying the existence of toxins in blue-green algae. Again, another paper was also published on the same, the fatty acids, but the approach was a bit changed, because in the detection of the fatty acids, someone needs to do derivatization, and therefore we tried to investigate also on the effectiveness of a bit greener solvents to achieve this analysis, trying to avoid adding more contamination to environment at a time you're trying to solve other problem. So we are trying to find out a more friendly way, but also we had some more information on the existence of fatty acids and in blue-green algae, and we tried to check how could they be correlated to the existence of cyanotoxins. Now, how do the human get exposed to algae toxins? It's simple, through drinking water. As I said from the beginning, these compounds are soluble, but also are stable, which means they can go through the water treatment plant and eventually be found in the drinking water, of which we normally consume daily. But again, during the recreational activities in the lakes or rivers which are being affected by this blue-green algae, as you can see on the photos appended on the side, on which while somebody is swimming, there can be a possibility of actually being infected through oral or through skin dermal infection. But also during the showers, there can be a possibility of inhalation of these toxins, but also through skin penetrations. So these are some. There might be more ways of being exposed to, but these are the common ones and easy for someone to be affected by the toxins. Algotoxins and other secondary metabolites are released into water bodies due to cell lysis, as I said, but this could not be left just like that. We had to conduct a research, a study on how much do the algocell lysis add in terms of the contaminants in water. So we did that study, of which the first thing we found that the cell lysis, or the death of the cells, normally occur naturally when these cells encounter different environmental stresses. It might be light stress, it might be temperature stress, etc. So when they encounter stress, before dying, they just actually produce a lot of compounds of different types as a part of trying to rescue themselves. So this a kind of a moment. This is a type of moment where the production of more secondary metabolites is actually happening. And for that case, we try to check what kind of compounds are actually produced and what could be the impact into the water bodies in terms of concentrations and all that. So the toxic metabolites released during the cell lysis definitely includes the microcysteines and other lipids, including the long chain fatty acids, and especially the polyunsaturated fatty acids, the PUFAs. So as I said at the beginning, we have the data or the study going on the microcysteines, and I'm not ready to share with the data at the moment, as we are still confirming a number of issues. Thus, I will share with you on the fatty acids, which were investigated to see what impact to the water bodies is actually brought about by the cell lysis of algal blooms. That's the study for investigation the amount of long-chain fatty acids added into water due to algal cell lysis and its effect on water pH was conducted, and its findings actually were published in the year 2015. The question which I've already answered is why fatty acids? Once there's toxicity of microcysteines is enhanced by the presence of polyunsaturated fatty acids from the cyanobacteria, which is the blue-green algae. So that is the reason why we started making a study on the fatty acid levels, trying to find out the connection between the two. And then fatty acid being easier to be detected, we thought, or we are thinking, it will be a good biomarker to report in terms of the correlation with the toxins, of which actually its research on the other part is actually on ongoing. So the effect on water quality. So because of that, the effect on water fatty acids have been reported to cause inhibition of growth in fish, just like the microcysteine. They do affect the other aquatic organisms, including fish, and therefore we need to know what are the levels, what happens when you have a large amount of algal blooms, and what happens if they die in the water bodies. For that case, we'll have to minimize, or we have to make sure that the algal blooms are removed from water bodies before the death of the blooms, if we are to avoid the contamination of that water. So the extracted fatty acids are commonly determined through derivatization to obtain non-polar fatty acids, methyl esters, as I said at the beginning, that if you want to detect microcysteines, it's a bit difficult if compared with detection of fatty acids, of which can just be done by using a gas chromatograph, and basically gas chromatograph mass spectrometry. And for that case, it is also more easier to detect fatty acids in terms of fatty acid methyl esters, because they become non-polar, and for that case, they become more volatile, and also they are more sensitive to the GC-MS detector, and therefore we have to know the importance and the necessity of conducting or derivatizing these materials to obtain easily detectable compounds in terms of fatty acids. So in our studies, the detection was achieved based on massive fragmentation, comparison of retention times with that of respective standards, and the use of MS library. So we did that to confirm the results which we actually eventually obtained from different analyses which I have showed, and also publications we went through, we were able to obtain. So the question of why derivatization, as I have explained previously, it's actually to break the bound compounds. There is a possibility that these compounds are existing in waxes or in terms of long or big molecular esters, and therefore you just break them. to get the component of fatty acids and the detection and see how much is in there. But to increase the volatility, as the gas chromatography detection needs the compound to be volatile enough to be able to vaporize and to go through the GC column. Otherwise, it may be trapped into the column. But also, there is identification, which I said, because once you derivatize to get a fatty acid methyl esters, you will form a particular fragment, which is the most stable in fatty acid methyl esters, particularly for the saturated one, with a mass to charge ratio of 74. And this one cannot be missed in the GC-MS chromatogram. So that's why it is preferred to derivatize when dealing with the detection of these fatty acids. So we had to study the variations of this fatty acids due to algocelluloses. We detected the amount of fatty acids obtained from both dead and alive algae. So we had to have the cells, the dead ones, and the ones which were alive, then tried to extract the contents of fatty acids and see what happens before and after death. So if you look at these ones, we found that new fatty acids were identified in the dead algal cells and its water. So there was these cells which actually died. We extracted them to see the lipids which are in there in terms of fatty acids, but also we took the filtrate water to check also how much was added in that water. So we detected a number of fatty acids in terms of classes. As you can see, C16s were with isomers. We had C18s with the isomers. But again, we had those which were detected after the death, and which you can see from the first diagram or the first graph, which was actually extracted from the GC-GSTOF-MS, you will see that there was no extra signal, of which on this side are indicated, on the right-hand side are indicated as additional peaks, which were observed in the dead cells. What does this mean? It means before the death, these cells were subjected into different stress, which caused their death. Now, in that process, there was a struggle to retain their survival. And for that case, they produced the different compounds. And that's why we have additional peaks on the analysis, which was done in the dead cells, and also the water filtrate, which was from the dead cells. So we did the comparison, tried to compare the amount of fatty acids which are obtained from a sample of live and dead algal cells. And then you could just see the black ones, the black bars are actually the live ones, but the grayish one are for the dead water, the water filtrate which were obtained from the dead cells. So if you look at that one, you can see that from the dead, actually the concentrations of some of the fatty acids were really high, particularly the unsaturated fatty acids and saturated C18 were really very high. And this could just give us one message, that there is a possibility, because the saturated C18 in here is actually so reduced, indicating that there is a process when there is algal cells struggle to retain their survival, they actually desaturate the saturated fatty acids to produce unsaturated fatty acids, of which are mainly actually used to encounter different stressful reactions in the body. So the second histogram, as you can see, it actually amount of saturated and unsaturated fatty acids being compared for water filtrates from arrival and dead algal cells. We're trying to check now in terms of saturated and unsaturated. So the unsaturated is actually, as I said, it is high. Now, the variations of fatty acids in live and the dead algal cells were actually compared in terms of percentage increase or percentage decrease. In the live algal cells, which were actually tested, there was a decrease in the dead, which means when the cell lysis occurs, most of the compounds actually are released into the water bodies. That's why if you extract the dead cells, you'll get actually low amount of the compounds, meaning that it leads to pollution, contamination of the water to such a high level. But when we checked for the unsaturated, we found that there was an increase in the dead cells, of which you could also see that, as for the reason I said at the beginning, that there was a kind of desaturation process as a way of trying to survive the stress. There was an increase of 10.5%. Likewise, in the water filtrates, also we saw the increase that the saturated fatty acid had a slight increase of 6.72% because we had water filtrate when the algal cells were alive and water filtrate when the algal cells were dead. So when they died, the saturated fatty acids were actually were added into the water, indicating that the cell lysis definitely leads to the contamination. That much. If you look at the unsaturated fatty acids, you can see the increase is more significant, which means they were formed during the struggle of survival caused by the stress which were subjected to these cells towards their death, and therefore they produced more unsaturated fatty acids to the extent that the increase in the water filtrate was actually above 52%. What does this mean? In the big picture, we just see whenever this cell lysis happens, we should expect to have a lot in terms of concentrations of either toxins or other secondary metabolites will be added into water bodies. And therefore, our work, which is ongoing now, we are trying to find a link on how we can use the fatty acid variations to report the toxins. And then from there, we shall come up with a way which will be more friendly. Instead of dealing with the toxins, we deal with fatty acids, which are a little bit not that toxic. So these two tables here, they are still insisting and showing on the data which were obtained and the kind of two compounds which were observed in the dead cells and the water filtrate of the dead cells, of which could not be identified, but generally were confirmed to be fatty acids. But we were having no standards for our final confirmation. But these were additional. They could not be found on the live ones, they were found on the dead. So indicating that when these cells dies, they add more compounds, more chemicals into water beyond the normal compounds of which can be found in the living algal cells. So in the big picture, what happens? We observed variations in the levels of fatty acid indicate in a similar situation on some toxins when algal cells are subjected into stress prior to cell lysis. This is a big picture of which actually we are seeing, although we are yet to conclude with our experimental data. The significant increase of unsaturated fatty acids compared to saturated fatty acid is attributed to the desaturation of fatty acid which takes place in algal cells to survive the stress. Because if you want them to die when we are doing our experiments, we subjected them into the environment where they could die. So they were going through different stresses, and therefore trying to survive for that. The physiology might have led to that kind of desaturation of saturated fatty acids to produce more unsaturated fatty acids. So we published this paper on the effect of natural blue-green algae cell lysis on fresh water quality. These are kind of the work which have been covered so far. And the ongoing work, definitely once it is completely done, will be communicated with the scholar world for information. Lastly, I would like to acknowledge my working colleagues. Of course, I didn't list them here, but the team I've been working with in our laboratory, but also the University of Dar es Salaam, one for getting into this collaboration with PSGR Krishmal College for Women and enabled this to happen, this conference to happen, but also the PSGR Krishmal College for Women for actually coming up with this initiative, of which we collaborated together to ensure that this type of conference is happening. I thank you for your attention.
Thank you, sir, for the wonderful session. Participants can post your queries in the chat box or raise hand. No more queries. We thank you, sir. Participant can put their feedback in the link available. Moving on to the next technical session, I would like to invite an esteemed chief guest of the day, Dr. Lidva Mayawaska, lecturer, Department of Physics, University of Dar es Salaam, Tanzania, to enrich us on the topic thin film based solar cell. What is the culprit of the low VOC in the Kersite solar cell? To give us an introduction about the chief guest, I request Dr. N. Priyadarshini, Assistant Professor, Department of Physics, PSGR Krishmal College for Women. Please, ma'am.
I extend a pleasant good afternoon to the participants over the globe. International Conference on Breakthroughs and Approaches in Contemporary Scientific Research is a golden opportunity for the students to nurture their young minds. I take great pleasure in welcoming Dr. Vatiho Falls Vakayuza. Professor holds a PhD degree in electrical engineering from Karlsruhe Institute of Technology with a dissertation on the development and characterization of co-evaporator CZT selenium solar cells. Currently, he is working with the University of Dar es Salaam, Tanzania, as a lecturer in the physics department. He is interested in working with thin film based solar cell. At present, he has been involved on the solar thermal project, Solar Cooking for Institution, as one of the alternatives for inefficient and polluting cooking technologies. Thank you, sir, for accepting our invitation to deliver a lecture on thin film based solar cell. We are honored, and the participants are fortunate enough to have such an eminent resource person in our midst to enrich our knowledge in the entanglement of fundamental research. I once again welcome you all for this fruitful occasion. Thank you, one and all.
Yeah. Struggling with sharing. Hello, can you hear me? Yeah, thank you, Chairman, for the introduction. Yeah, it's Chairman say, my name is Ritiko Forts Makusa, and I'm currently working with the Physics Department of University of Dar es Salaam. So my today discussion will be based on a thin film solar cell, but particularly to the Kestrite solar cell. So I'll say the topic will be a little bit far away from the chemist. So a lot of physics concept will be discussed and shared today. So, yeah, before I'm going into details, let me introduce the outline of our today's discussion. And because we are talking about the solar cells, we need to have a view about the thin films, the photovoltaics, and why do we need the thin films in general, and what are the challenges of solar cells based on the CIGS and cadmium telluride material. And after that, we go into a Kestrite, which will be the main discussion today. So with the Kestrite, we'll try to look on the structure of the Kestrite and how the device look like and what are the challenges. And with the Kestrite, we are commonly assuming that the interface between the absorber and the buffer, which is cadmium sulfide, is the main limitation toward the high efficiency devices. So today I'll give the highlight that this is not true, and there's some experimental evidence which prove that this is not true. And also we discuss go into detail in the issue of andesite defect, and that andesite defect are basically from copper and zinc. And then we'll end up our talk with a discussion on the silver incorporation in the Kestrite and its impact on the open circuit voltage. So first we need to think, why do we need PV technology? Yeah, here we have some few pictures, and I took this picture with the view that to try to elaborate that with a PV technology, you can get a power from very few watts, like the first solar panels. It's very small, so you can get several, say, very few watts to several megawatts, like a second picture. And also with PV technology, you can use it in a remote area, especially in the village, whereby there's no a grid connection. And also you can use a PV technology in a space in a telecommunication. And because you can install from very few watts to several megawatts, you can use it to do several activities like water purification. So it's like the bottom picture is a system which was installed in the northern part of Tanzania. And the main idea of this system was to try to remove fluoride from water. So the second picture, which is some bottles of water, you can see the first bottle is water which is highly contaminated with fluoride, and the second bottle is after purification. So the system was powered with a PV system. So to that sense, you can say, yeah, with a PV technology, we could somehow try to eliminate the issue of water or the issue of disease and also the issue of food. So in general, I would say PV is very, very useful to us. But if you look on the PV market, about 95% is from silicon. So I would say the silicon is controlling the market. And the main reason is based on the efficiency. With the silicon, you can get solar cells with efficiency up to 26.7%. This is for monocrystalline, and for multicrystalline is 22.3%. So silicon, I would say, is really doing very, very nice in terms of the marketing, and also it's in terms of stability. The problem with silicon is processing because it needs some wafer. So processing wafer is very, very costful and very, very energy demanding process. And also with the silicon, I think we know that silicon is in direct band gap. So it means you need to have a very, very thick layer of silicon to have a nice absorption. So if you have a very, very thick layer of silicon, it means you cannot make a silicon, or you cannot integrate a silicon in the architecture. So the easiest way to do or to deal with architecture or to deal with a flexible substrate is to go to the thin films. So the thin films, it means you can choose any substrate you want. And also the processing cost of the thin films is very, very, very low. If we compare that, I mean, the terms of cost and the term of the choice of the substrate, it means even it's doing very, very well in when it comes to the energy payback time. And with thin film solar cells, especially with CIGS, it's possible to reach the efficiency up to 23.3%, which is more or less close to the silicon. And again, with cadmium telluride, it means also we can reach the efficiency of 22.1. I'd say, again, it's very close to silicon. So it's better to go to the thin films and try to get power from thin film solar cells. But the main problem, especially if we go to CIGS, the material itself, it features some scale element like gallium and indium. And also, if you go to cadmium telluride, you find there's a tellurium is not very, very available. And also you have cadmium, which is really, really toxic. So the easiest way is to go to the CIGS and try to remove indium and gallium. So you can place indium, and it means the half of indium will be occupied with zinc, and the half of indium again will be occupied with tin. So if you do that, you change the crystal structure of the material from CIGS, which is chalcopyrite, to cassiterite. But again, with the cassiterite, because it's a new structure, it means it has some unique properties or some similarities with the CIGS. So first, we need to point out the advantage of cassiterite. The cassiterite, because we are using very abundant material, zinc, tin, and copper, it means we are going to less toxic and less abundant material. And good thing, the material itself has high absorption coefficient. So we are talking about the absorption coefficient to 10 power 4, which is absolutely small, similar to that of CIGS. And good thing, Kesselrite again is direct band gap, like CIGS. So we don't need a very thick layer to make a solar cell. And because it's a direct band gap, and we try to derive the structure from CIGS, it means we can also tune the band gap like what CIGS are doing. So the possible way of tuning the band gap for Kesselrite is either by allowing the chalconide, it means you are mixing sulfur and selenium, or you are allowing tin with the germanium, or you are allowing copper with silver. So via that, it means you can tune the band gap, and again, you can engineer the band gap in any shape you want. But the main problem of Kesselrite is the coefficient efficiency, because up to now, the recorded efficiency is 12.6, which is very, very far away from the CIGS. And this challenge could be traced back from the open circuit voltage and some part of the field fact. So when we are looking on the open circuit voltage, we are normally trying to link it with a band gap. And if we link it to the band gap, we say that this is an open circuit deficit. So if you take the band gap minus a open circuit or measured open circuit voltage, you can determine the VOC deficit. But the cause is still an open question. There's no clear argument what is happening, and we are normally trying to link it with the interface recombination. So when you are saying interface recombination, it's a recombination at the PN junction. And also we have small grains which are contributing to the problem, and some of the secondary phases, the presence of secondary phases. And these secondary phases come from the structure of Kesselrite itself. It's a little bit complicated because you are dealing with 4 elements. So controlling the phases of all 4 elements is not an easy task. And another issue is copper zinc at site. So you find copper and zinc interchange their position. This causes the band tearing and could somehow impact the performance of the solar cells. And there's some trial which is somehow was mainly try to suppress the formation of copper and zinc andesite. There people are trying to think that let's try to integrate or to incorporate element, or let's try to alloy copper with silver, because copper and silver, they have a big difference in atomic radius. It means also silver and zinc will have different atomic radius. So if you do that, it means it's possible to suppress the formation of a copper and zinc andesite. And hence you can enhance the growth of the material, and at the same time you can try to tune the band gap. But the amount of silver added in the Kesselrite is very crucial, because if you have too much silver in your Kesselrite, you change the Kesselrite from the P-type semiconducting material to N-type semiconducting material. So it's very, very tricky, and you need to control the amount of silver in the material. But in this talk, we'll try to go into details on how we could talk about the potential losses mechanism, I mean the recombination channels in the device, and how we can minimize, I mean the way forward. The view is to try to find a way to improve the performance of a Kesselrite solar cell. So before going into the details, let's go back to the physics of the solar cell. And physics of the solar cell. When someone say solar cells, you have to say the solar cell is a PN junction device. So don't stretch up too much. A solar cell is a PN junction device. So if it's a PN junction device, we say it's a diode. So always in the dark, when there's no sun, a solar cell is a typical diode, but not a small diode, rather than it's a big diode. So when you put a sunlight or under illumination, the sunlight will be absorbed by solar cells, and this process is taking place in the P side of the solar cells. And the moment is absorbed, it will generate electron hole pair. And if we manage to separate those electron hole pair, you can get charge and you can get power. And that separation is always taking place at the PN junction. And the main reason it's taking place at the PN junction because there is electric field in the PN junction. We have a P side and N side. Remember, if you try to fuse the two things, you can force the electrons to go in this side and the holes to go in this side, and you can create some positive charge and negative charge. If you have a positive charge and negative charge, you have electric field. So that electric field is very useful in separating charges. So finally, you can get power. But how can we realize this in the lab? So because we are dealing with a thin film solar cell, it means we have a choice of choosing the substrate. To our case, we are starting with a very cheap glass substrate. It's a soda lime glass substrate. So it's like a window glass substrate. On top of the window glass substrate, we are sputtering molybdenum. After moly, we are putting some precursor, which is always a mix of copper, zinc, and tin. And sometimes it's copper, zinc, tin, and sulfur, and sometimes copper, zinc, tin, and selenium, which depends on the choice. But for our laboratory case, we are normally using copper, zinc, tin. So we are starting with a pure metallic precursor. So this metallic precursor is subjected at high annealing temperature, which is about 500 degrees centigrade, in the presence of tin and selenium. So the moment you do that, you can change your precursor from the metallic to a semiconductor material, which is CZTS. So it means to this case, you have only absorber. And I think later on I'll discuss why or what is happening to this moly diselenide layer. So when you have this layer is a P-type, and we need to have a PN junction. So to get a PN junction, we are depositing a very thin layer of cadmium sulfide. So after that, we have a PN junction. So we are now in a position of say, yeah, we have a solar cell if we put zinc and zinc oxide as a metal contact. And finally, we are normally scratching our sample to get a small area. And the idea is to minimize the current. And normally we are working with the composition, I mean metal composition, I mean the composition of copper and tin and zinc in the range of 0.75 to 0.85. So we say we are working with the copper poor cassiterite and slight zinc rich cassiterite. The idea is to try to minimize the formation of unwanted phases, I mean the secondary phases. If you have a copper rich, it means there's a possibility of getting a copper sulfide in your material, and we don't want that to happen because the copper sulfide has a metallic behavior. So if it's in the material, it will act as a shunt and can destroy the devices. But someone could ask why we are running to a zinc rich, because again, if you have a zinc rich, you can get a zinc selenide. And if you have a zinc selenide, it means that is a secondary phases. And normally the study reported that zinc sulfide or selenide always situated at the back of the absorber. So if it's at the back of the absorber, will act as a dead cell, and somehow it could impact the solar cell performance, but not in the significant amount compared to copper selenide. So let's see how the solar cell look like, especially after the lab. I think now we need to follow this structure. So if we take the structure, I mean the devices from the lab, and try to cut and observe it under the electron microscope, you can see we have several layers. So we have a top layer, which is zinc oxide, and I could say it's a zinc oxide plus zinc oxide of aluminum. So we are using that layer as a electrode, so it takes the charge from the absorber. But beneath this zinc oxide, there's a cadmium sulfide, and the cadmium sulfide is an N-type, so they act as a N-type, and we are normally called a buffer layer. And again, we have the absorber, which is a cassiterite itself, and we have a moly diselenide, and again we have moly. So we are normally getting a relative thick layer of moly diselenide. I think at some point I'll explain why we are getting this thicker layer. So in terms of band diagram, and I'd say the band diagram of Kestrite is look similar with that of CIGS. To both cases, we can get either cliff band alignment, or we can get a spike-like band alignment. So it's depending on which Kestrite you are working. So if you are working with a pure sulfide Kestrite, expecting to get a cliff-like band alignment. But if you are working with a pure selenide Kestrite, we are expecting to get a spike like a band alignment. So again, if you are making with a mixture, I mean the mixture of a pure sulfide Kestrite and pure selenide Kestrite, it depends on the composition of the selene and the composition of the sulfur. So if you are in the selenium rich environment, it means you are creating some kind of spike band alignment. And if you are in the sulfide rich region, you are creating some kind of cliff band alignment. And this is very, very important because it strong impacts the devices. So let's see, we have one devices which was fabricated in our laboratory, and in our laboratory we try to adapt the co-evaporation. It means the precursors formed via co-evaporation of all three metals, I mean copper, zinc, and tin, and then selenizes tin. And then after you make a solar cell, you can try to start the quality of the solar cell. It means you have tried to look on the quality of your absorber. Yeah, so we have a decent number of efficiency because it's around 7%, and you have a good current, but the VOC and the fill factor is not at a good standard. But the things I want to address here is the crossover. It means we are trying to look on the curve when there's no sun, and the curve when there is a sun. So you can see these two curves are not perfectly superimposed. And this upsets raise a lot of questions. What is happening and why this is happening? The most, I would say the easiest way to quantify that is there is somewhere in our device, there is a barrier height, or there is a photosensitive material inside our devices. And to deal with that, we need we must investigate how the open circuit voltage is responding with the temperature. So we perform the VOC temperature dependent and try to see how it's happening to our devices. And this is possible, or upside could be realized if we compare the activation energy from this graph with the band gap of the material. The activation energy for our devices is around 0.8 electron volts. And if you look on the band gap, because we're working with a pure Kestrite, a pure selenide Kestrite, it means the band gap is around 1 electron volt. So it's like the activation energy is lower than the band gap. This means that we have some kind of a barrier at the interface. So it means the interface recombination is controlling everything in our solar cell. And we are not alone, or we are not the first one to observe this one. There's one guy from US also observed the similar situation, and for him it was very, very, very worse. So for him, we tried to combine or to compare the crossover in Kestrite and crossover in CIGS, and we are sometimes try to use a CIGS because Kestrite has some properties or similar properties with the CIGS. You can see in the left-hand side of the graph, the red one is for Kestrite, and the blue one is for CIGS. You can see CIGS is really doing nice because the crossover is very, very far. So you can really superimpose the dark IV curve and the light illuminated IV curve, but you cannot superimpose the IV curves of Kestrite. And this is, as I suggested, it could be connected with the interface recombination, and also probably there is a blocking layer at the back interface. So to address this, we try to assume into two things. First, probably our Kestrite is forming a cliff like a band conduction band offset. It means instead of getting a spike, we're getting a cliff, and this could somehow try to prevent the carrier to move, and if it's a carrier prevented, they will combine. Or we are getting a spike, so it was some kind of confusion. But from the literature, they say, yeah, for the case of the spike, for the case of selenide, spike interface is expected. So it means we need to answer this question: why are we getting a crossover in our devices? So this was forced us to go back to the chemistry of cassiterite. If you look at the cassiterite itself, is not very, very stable at a high processing temperature. So normally in high processing temperature, cassiterite tend to decompose into different phases, and commonly it says could either form copper selenide, or copper or zinc selenide, or tin selenide. So here in this equation, X try to represent the chalconite. It could be either sulfide or it could be either selenide. And the thermodynamic process of this equation, if you want to control, to stabilize this reaction, you need to support the reaction with more chalconite, or to support the reaction with some elemental tin inside. And we are choosing tin because the melting point of tin is very, very, very low. So we are expecting, if you manage to create enough pressure of chalconite inside your material, or if you manage to create enough pressure for tin chalconite or tin selenide inside your material, you can control decomposition. So you can stabilize the process. So what we did, we try to incorporate tin in our devices, in our process. It means in our annealing process. And after incorporate, we try to look on how the device is responding, or how the quality of the device look like. Good thing, after that, we get some gain of the efficiency, because the efficiency goes up to 7.5, which I would say is a nice, I would say it's a good number. And the main gain was from open circuit voltage. So we obtain a nice open circuit voltage. But the strength thing, the crossover is still visible. So you cannot superimpose the dark curve and the illuminated curve. And to address this, we try again to check the dominant recombination channel in our devices. So when you have devices without tin, you can see the black one, you have activation energy around 0.7, which is similar with the what I showed earlier. But when you incorporate tin in a processing, the activation energy improved, and we get the activation energy which is close to the band gap of pure selenide cassiterite. So it means if you incorporate tin in your process, you can control the interface recombination. But the issue here is why we are still getting the crossover. And if you go back to the structure of cassiterite, you can see in the SM image, we are getting a relatively thicker layer. So it means this crossover is not connected with the interface recombination. It could be probably connected with this thicker layer. So with this more diselenide layer. So more diselenide layer, look, we have a mold, which is a metal, and we have more diselenide layer, which is a semiconducting. And again, we have a semiconducting material. So probably the band alignment at the back is not at the good point. That's why we are getting that crossover. So to understand that, we try to go into a different literature to see what is happening to the mold when we are dealing with a cassiterite. So always, if you go to the literature, they say cassiterite again is not stable when it is in contact with moly, especially at high processing temperature. So normally at high processing temperature, cassiterite will react with a moly to form secondary phases. So it means if this happened at the back of your devices, you have a lot of the unwanted phases, like a copper. And if you have a copper, you'll be in a very, very big problem. And again, if you have a tin, you'll be in a very, very big problem. Again, the literature suggests that if, again, you have a tin could react with a moly, and if it reacts with a moly, it could form moly diselenite. And again, moly itself, because we want to control the composition of a cassiterite in the high processing temperature, it means we are trying to force the reaction to take place in a high Chaconoid partial pressure. So if the partial pressure of Chaconoid is very strong, it means a lot of Chaconoid will go through and attack moly and form moly diselenide. This is why we are getting a very, very thicker layer of moly diselenide. So there's a different approach which has been suggested. One approach is to use they called barrier. So that barrier will try to prevent a lot of Chaconoid to attack the moly. Or I could say the barrier again will somehow prevent the interaction between cassiterite and moly. So if you do that, it means you can control the thickness of moly diselenide. There's a nice research investigation which was done, and from that research you can see we have a LED light, I'd say the LED curve. The LED curve, we have say, is an illuminated curve from the cassiterite with a blocking layer, I'd say with the intermediate layer, which prevents the interaction between cassiterite with the moly. And again, the black one is cassiterite without that intermediate layer. So you can see with the black one, you can see the crossover is still visible. I mean, you cannot superimpose a dark and illuminated curve for cassiterite. But for the case of the devices with the intermediate layer, you can see the crossover is somehow suppressed. So it means you can suppress the formation of moly diselenide in the cassiterite. In the same time, you can improve the quality of the devices. Again, even the interface recombination, I'm saying, is much better when again you have an intermediate layer in your devices. Yeah, another issue when we are coming to the problems of cassiterite, so this is a second challenge, is a minority carrier lifetime. So minority carrier lifetime, we are looking on the minority carrier lifetime in the P side and always impact the open circuit voltage. And this could be realized by doing a measurement using time resolved photoluminescence. And here again, we have another work from Professor Mitz, and he tried to compare the carrier lifetime for CIGS and carrier lifetime for cassiterite. You can see the blue one is the carrier lifetime for CIGS, and the red one's carrier lifetime for cassiterite. You can see the band gap of the two materials is more similar, but the free carrier lifetime are completely different. We are getting better carrier lifetime when we are dealing with the CIGS rather than with cassiterite. And this could be somehow linked with the formation of the deep defect in the band gap or the presence of the secondary phases in the cassiterite. And as I said earlier, it's not easy to control the formation of a single phase cassiterite in the material because you are working with a copper poor cassiterite and slight zinc rich cassiterite. And also, it has been demonstrated that the carrier mobility of cassiterite is very, very low, and that low is due to the presence of a defect which could contribute to the scattering, and also the issue of localization of a carrier also could contribute to the, or could somehow impact the movement of a minority free carrier in our devices. So in another way, I could say those two things could strong impact the performance of devices. Another issue with cassiterite which I say is commonly, and I say if you in the community, we are always trying to assume this is the main issue, is a copper zinc antacid. So you find the position of copper in zinc, and you find zinc in position of copper. So now try to look on the two crystal structure. One for now we can assume it's ordered. For now it's ordered, and another one is disordered. I'll explain later on what it does mean. So just look on the ordered, and if you try to cut at this point and try to view the crystal structure, I mean the top view of the crystal structure, you will see, or you can clearly identify you have a copper and zinc, or you can separate copper and zinc in the crystalline. But if you have a disordered crystallite and you try to view at that point, you can see you have you can have interchanging, say the copper and zinc will interchange the position. And what do we mean by disordered? Because we are processing crystallite at very, very high temperature, and we are normally quenching our process to avoid any decomposition in the crystallite. Always we are getting a disordered crystallite. It means you find sometimes we are getting a copper in position of zinc, or we are getting zinc in position of copper. So we are normally trying to say, yeah, if you are getting this, it means we are creating some sort of a band terrain. So you can create some kind of a band fluctuation in your devices. And you can measure how much you are deviating from a theoretical band gap by trying to do ordering. It means, again, eating the crystallite at a certain temperature and try to cool it very, very, very slow. Or heating the crystallite at a certain temperature, we are calling that temperature the critical temperature, and try to cool very, very rapid. So you can order and disorder, and you can start the band gap. So here, there's a work which was done to emphasize or to check if there's any change in solar cell performance if you have ordered crystallite and if you have disordered crystallite. So if you compare the two, the difference is only around 41 or 40 millivolt. So it means we don't get a big impact when we subject our crystallite in disordered conditions. So in another way, I could say a copper zinc antacid is not a main cause of poor performance of crystallite. Now, although this is not the main cause, but we need to control those defects because we don't know how it's connected with the band tail. And we know that the band tails defect inside the material would somehow cause non-radiative combination to our devices. The only way to play with this one is to try to reduce the band tail effect in our devices. And the easiest way is to try to play with the defect of copper and zinc. It means if we have, or if we incorporate any element between copper and zinc, which could somehow suppress the interchange between copper and zinc, will be in a better position to answer this issue. So one way is to incorporate silver, and silver is expected to have a high atomic radii than copper. So it means we have a different atomic radii with zinc, so you cannot allow the movement of silver to the position of zinc and its position of, and zinc to the position of the silver. And good thing again with addition of the silver, it's expected to improve the grain quality. So you can see in this SM image, the first image is the top view of a crystallite without silver, and the last one is a top view of a SM image with a certain amount of the silver. You can see the grains are completely different. And as I said earlier, with the silver, you can even tune the band gap. So there is a wide range of tuning the band gap. You can start from a pure crystal material to some point, maybe to 1.2 electron volt. So if that is possible, it means you can even engineer the band gap. So if you engineer the band gap, it means you can create some kind of a V-shape band gap, or say V-shape to absorb the material. So this V-shape, say, is a promising technique which was used in CIGS technology, and via this one technique, they obtain a very, very high performance devices. So let's see how silver could somehow suppress the band tailing. So the easiest way is to look on the average energy and see how the average energy is decreasing with the amount of silver. So again, we have this work from one, and they try to compare average energy with the amount of silver they added, and the average energy was really decreasing with the amount of silver added in your material. So it means if we're increasing the amount of silver in cassiterite, we are reducing, or we are suppressing the formation of copper, zinc, anthracite. But there's something we need to take care here. If you put too much silver in your material, you will change your material from P-type to N-type. And if you have N-type, it means you will not create any PN junction, and it means you will not have any solar cell. So let's see the numbers, how in comparison, the silver is connected to the device's performance. So I'll start with when we incorporate silver in your material, and at the same time, we don't want to tune the band gap. So it means we are trying to put the silver in the material and try to control the grain growth without compromising the band gap of the material. So if you do that, you could improve the open circuit voltage, so you can get a very nice efficiency. But again, if you add the silver and at the same time you are tuning the band gap, it means you are getting more voltage, but at the same time you are increasing the deficit of your devices, and at the same time you are compromising the current of your devices. But the good number is when we try to add the silver, and at the same time we are controlling, or we engineer the band gap. You can achieve a very, very good efficiency, which is 11.2, and again, you can achieve a very, very good open circuit voltage. So in a simple way, I could say silver incorporation is a promising approach toward improving the performance of cassiterite solar cell. Yeah, to sum up, I try to point out that interface recombination, I mean the recombination at the PN junction is not a main culprit for poor performance in the cassiterite. Again, I try to point out that copper zinc anthracite is not a main cause of poor performance in cassiterite solar cells, but Shockout lead hole recombination, which is somehow connected with the deep defects in the band gap, could be the main cause, and also the presence of secondary phases again could be the main cause of a poor performance in cassiterite. The low carrier mobility, which is somehow connected with the minority free carrier time, is also held as a culprit for a poor performance in cassiterite. So to think how could we go forward, I mean, how could we improve cassiterite solar cells? We need first to improve the quality of the absorber. So we need to make an absorber with less secondary phases and less unwanted defect, especially those defects which are situated at the mid of the band gap. And also we need to investigate the issue of a back contact, because up to now there's no clear idea on the band alignment at the back of our devices. So this could be also be the main cause in limiting the device performance. And probably moly is not a good back contact for cassiterite because it's not stable, and we don't know the band alignment or the physics behind the moly and the cassiterite. And also the incorporation of silver is more promising, And I think we need to do a lot of work with the Silver Incorporation because there is a green light to high efficiency when it comes to the incorporation of Silver. Thank you. That is the end of my talk. So if there's any comment, question, I'll be happy to respond.
Thank you, sir, for such an interesting session. This session is open for discussion. Participants can post your queries in the chat box. Participants can post your queries in the chat box.
Yeah, there is one question. It says, why did you choose a cassette thin film solar cell? What benefit for cassette compared to stannite structure? Thank you. To a very nice question. Based on the thermodynamics principle, I think cassite is much stable compared to stannite structure. And again, so this is some kind of tradition in cassite community. We are always try to ignore the issue of stannite structure, but actually, sometimes you can get a cassite and stannite structure at the same time. Yeah, but this is like a traditional. We are always ignore the issue of stannite structure because of the thermodynamic principle. It is less stable compared to cassite. Yeah, there is another good question. They say, how could we identify secondary phases in the cassette absorber? The easiest way is to perform XRD measurement. With XRD measurement, you can identify which phases do you have in the cassette. But again, it's tricky because it's not that easy. If you look on the crystal structure of the cassite, it somehow has similarities with zinc selenite. So you cannot resolve zinc selenite using cassite. So we are normally using two techniques to identify and quantify the secondary phase in our material. First one is the XRD, and another one is Raman spectroscopy. But with a Raman spectroscopy, again, it's very tricky because it's a surface sensitive measurement technique. It means you can just probe to a very few nanometer in your Keswick layer. So you can get only the surface information. And sometimes we do assume the surface information are enough because we are interested with the formation or the secondary phases at the interface. But there is another trick which people are commonly try to identify the number of, the secondary feathers in the back of the thin films. The easiest way is to create a wedge from the surface to the back contact and try to probe or do a Raman measurement into a different position in your absorber. So from that, you can clearly quantify at what position in your absorber you have the band gap and at what position you're expecting to get a strong recombination to your devices.
If there are any questions, you can post your queries in the chat box.
Yeah, thank you. There's another question. They say tune the band gap. Tune the band gap. What ways would you follow? Yeah, because with the Keswick, we are always trying to copy some ideas from CIGS, and from CIGS they managed to get a high efficiency device after they're creating a very a wide band gap at the surface of the absorber and a narrow band gap in the mid of the absorber and a wider band gap at the back of the absorber. So we are also trying to follow that that trend. So it means if you try to make the surface of your Keswick, especially if you are incorporating a silver in your Keswick, so if the surface is a silver rich, it means you can increase the band gap. And if the middle or the middle point of the absorber is less, I would say, less with silver, it means we are getting a narrow band gap. And that if the back there's a lot of silver, you can widen the band gap at the back.
If there are no more questions, we thank the speaker once again. Participants are requested to fill the feedback link available in the chat box. Announcement regarding oral and poster presentation. The oral and poster presentation of today will be happening in the two slot. One slot from 2:15 p.m. to 3 p.m. IST and the second slot from 5 to 5:30 p.m. IST. The details of oral and poster presentation of slot 1 are displayed on the screen and the respective links will be posted shortly in the chat box. Participants are requested to take a break about 45 minutes and be back online by 2:15 p.m. IST for the oral and poster presentation. Thank you.
Section sasa ngapi? Tunaingiza.
Saa 8 hadi saa 9. Sasa iko kwenye 40. Mbona 43 yenyewe sio?
It's a presentation. Umeelewa?
Kwa hizo namba. Najana niambiwa posta yangu si namba 43 sio 45 sio 43. Kina pambana na 43.
Ila kana 45. Huko confirm kwanza.
Huko ni namba. Ni chat jana na kaniambia hivi kwa au tuulize. Muda ndio. Kwani sasa hivi ndio posta.
Na link atapost.
Hivi hapa hii wakati mwingine nasumbuaga shake utaona tokea wapi?
Unaona ni kwa hizi haiko mute.
Ndio unaweza ukaitumia. Ukiunmute ndio usikia.
Ukiunmute ndio na okay.
Yaani wakati mwingine nakuta nimeiweka lakini haisikiki.
Labda ulikuwa labda ya fungue hiyo.
Ngoja nifungue kabla ya kusaidia. Maana jana nilifungua.
Lakini mimi najua mambo ya Zoom. Ni nani?
Ndio nini?
Comment. Ya feedback. Ya sio baada ya share. Mimi sasa hivi ninaenda kuchukua chat na ku
Omi, njoo mara moja hapa library. Sasa hivi. Niko kwenye posta, njoo basi nisaidie. Yaani hapa sijui hii haisikiki, sijui haijaanza, sijui ndio nishajiconnect. Kuna hii link ya posta hii hapa. Na huyu yuko kwenye posta. Sasa sijui ndio nishaingia. Sijui ndio nishaingia.
Wewe hauonekani? Ndio link ya posta.
Hivi amezituma. Kwa hiyo
sasa ndio hii.
Mimi nilikuwa najiona huko. Nikatoa video hivi lakini sasa
usikose. Sasa unaingia. Hisi unaingia kwenye nani?
Sio na click tu. Au
ndio hii si ndio? Ndio yenyewe.
hivi tunaweza kujua ni
ndio hii. Basi tujue. Ndio hapo.
Au ndio present ready to go. Ndio hiyo sasa siku. Sasa mbona hii hapa sometimes ina sio ina shida huku, sio kuna sehemu sio inafanyaje. Kuna kama inagoma
Nimesha posta au
ni posta, lakini naona nikiingia sio kuna sehemu nakosea, najikuta najiona mwenyewe
uko peke yako.
Kuna hii hapa, si ndio? Hapa si ndio sahihi?
Hapa ni sahihi.
Kwa hiyo linki si inanili tena, ina maana nimeshaingia.
Nadhani yuko live. Nisha kushare tu. Ni zamu yako?
Tunajaribu tu kushare.
Kuna watu wanashare tayari?
Sasa sio kama ishaanza. Kwani wamesema ni break eh?
Sikumbuki. Hapo ipapi?
Bado sielewi. Ndio break hivi, si ile timetable ndio, kwa sababu si kuna lunch, si ndio ameenda lunch. Kuna muda kama huo ilikuwa lunch time saa 4 sijui.
Wow.
Hivi kwani nikijaribu kushare
Washa tuone. Nakubali.
imesema itastop nyingine kuna nini? This will stop other screen sharing. Do you want it to continue?
Hii account inabidi kustop.
No.
Kama kustop itakuwa.
Niangalie ile ratiba yao.
Au nipata nini nyingine ya Zoom? Nipata nini nyingine ya Zoom?
Kuna linki ya juu ilikuwa inago.
Akoma telefoni nyingine.
Kuna linki ambayo nani Dr. Kestari. Kumbe lunch time.
Unayo hiyo link?
Link.
Hello, ma'am.
Hello. Hello, Nirmala.
Hello, ma'am.
Nirmala, 2:15 தான் Nirmala session.
Ma'am, I'm
Start
audible,
பண்ணிடலாம்.
audible, ma'am.
Yes, Nirmala, you are audible, Nirmala.
Okay, thank you, ma'am.
Okay, Nirmala, thank you, Nirmala.
Okay.
Okay, Nirmala.
Amul, that is error, Amul.
What error?
This.
Sir, good afternoon, sir. Swami, sir.
Good afternoon, madam.
Sir.
Madam.
Good afternoon. Shall we start the session, sir?
Yeah, please, madam.
Yes, sir. Yes, sir.
Wonderful morning is over. Here is an afternoon wish for you to spend an incredible midday. Energetic good afternoon, everyone. We kickstart our midday with the oral and poster presentations. Announcement: the oral presentations will be held in two parallel sessions. The oral presentation number 10, 16, 23, 29, 52, 53, 54 will be doing their presentations in the same link. The oral presentation numbers 14, 22, 35, 36, 37, 38, 39, 40 are requested to join the parallel oral presentation Google Meet link. The poster presenters are requested to join the poster presentation Google Meet link, which is posted separately in the chat box. Now, I request Dr. R. Revati, Assistant Professor, Department of Chemistry, SGR Krishnamal College for Women, to welcome and introduce the chairing person. Dr. F. Ponusamy, Associate Professor and Head, Department of Chemistry, Government Arts College, Coimbatore.
Good afternoon to one and all. I deem it honor to welcome and introduce our session chair, Dr. S. Ponusamy, Associate Professor and Head, Department of Chemistry, Government Art College, Coimbatore. Sir is a gold medal holder in undergraduate and done his post-graduation in American College, Madurai. Sir has completed his MPhil and PhD at Bharathasan University under the supervision of Professor R. Jayaraman in Organic Chemistry. His research area is in the field of conformational studies. He has secured 16th rank in GATE exam in the year 1990 and passed UGC CSER JRF exam. He has published 101 articles in reputed national and international journals to his credit, and he has an ongoing major project funded by UGC for the grant of rupees 10.5 lakhs. Sir is a board member of various academic institutions and has acted as resource person, convener, coordinator, and organizing secretary in many national, international conferences and refresher courses. And added feathers to his cap, he is selected as 2000 outstanding intellectuals of the 21st century and selected as one of the leading educators of the world 2008 in International Scientist of the Year 2008 by International Biographical Center, Cambridge, England. We are honored on behalf of the Department of Chemistry, PSG Agricultural College for Women. I welcome Dr. S. Ponusamy and I request him to chair the oral presentation. Thank you, sir.
Thank you, ma'am. Presenter, restrict your presentation to 3 minutes and the discussion time will be for 2 minutes.
Okay. Shall I start, madam? Hello.
Sir, yes, sir. We can start, sir.
Yeah. Very good afternoon to all in this meeting. And the meeting, the International Interdisciplinary Virtual Conference on Breakthroughs and Approaches in Contemporary Scientific Research. First of all, I congratulate the Department of Physics and Department of Chemistry for having organized such a wonderful conference. And I thank the organizers for giving me a chance to chair the session. And I thank Dr. Amuda Madam for his nice words. Now we'll go to the session. First, I call upon OP10, I think as Nirmala Devi, to present the paper, please.
Yeah, good afternoon, sir.
Good afternoon.
Okay. So first of all, I thank the organizing committee for giving me the chance to present my paper in this international conference. So myself, Dr. S. Nirmala Devi, working as an assistant professor in the Department of Chemistry, Congo Engineering College, Perundurai. Title of my presentation is A Study on Removal of Basic Grade 29 from Aqueous Solution Using Biochar as Adsorbent. Ma'am, next one, ma'am. My presentation includes the introduction, objective, methods of preparation, resultant discussion, and conclusion. Next, ma'am. Next, ma'am. So water, the most abundant and also the most polluted natural resource on this earth. According to World Health Organization, by 2025, 1.8 billion people will be living in countries with absolute water scarcity, and 2/3 of world's population could live under water stress condition. So the present study is mainly devoted to the water pollution, mainly caused by the textile industry, because textile industry uses colored dyes. These dyes generates waste water, so which give cause of environmental concern. Next one, ma'am. So the substances like color, COD, BOD, pH, and TDS, which needs to be removed from textile wastewater, because the color, even at very low concentration, which hinders sunlight penetration, thereby affecting the photosynthetic activity of the, process of the aquatic plants. So these are some of the water treatment and technologies like coagulation, membrane filtration, advanced oxidation, ion exchange, and biological treatment. And among this, adsorption technology is of the prime importance because of its low operation cost and its simplicity. Next one, ma'am. The crucial factor that determines the efficiency of the adsorption process lies in the selection of a suitable adsorbent. An adsorbent should have high surface area, positive low production cost, and reusability. Next one, ma'am. Next one. Generally, in water treatment, activated carbons are employed as the adsorbent. Similar to activated carbon, biochar, which is a stable carbon-enriched porous material, which has been widely applied in soil amendment, water purification, and gas separation. So in water treatment, this biochar has attracted substantial attention because of its high surface area, high pore volume, and abundant surface functional group. And the estimated cost of biochar in Indian rupee is 18,185 per ton, which is approximately 1/6 the cost of commercially available activated carbon, which is in Indian rupees 1,10,885 per ton. Next one, ma'am. So with this, the main objective of this present study is to prepare biochar from an agricultural waste material and to characterize the material using nitrogen adsorption desorption isotherms, FTIR, FESM, and XPS, and to evaluate the adsorption properties of the prepared adsorbents for the removal of basic grade 29 from aqueous solution, and finally to study the effect of different batch adsorption process parameters such as effect of pH, effect of dosage on the adsorption process, and to study the adsorption kinetics, isotherms, and thermodynamics. Next one, ma'am. Next one, ma'am. So the adsorbent, that is the biochar, is prepared from the direct pyrolysis of the material at 700 degree for 2 hours to prepare the biochar. Next one, ma'am. Next one. Okay. So this is the SIM, that is scanning electron microscopic of the biochar, and this is the raw material. Compared to this raw material, the biochar possesses the selective force can be seen on the surface of the biochar, and this improved surface area result from the pyrolysis process. Next one, ma'am. Ma'am, next slide. So this picture shows the nitrogen adsorption desorption isotherms of the raw material and the prepared biochar. And this isotherm shapes were classified as type 1 of the IUPAC, that's 1985 IUPAC classification. So porous structure. Porous structure. And this table shows the bed surface area of the biochar, which is prepared in this study, which is 550. Which is comparable with the other biomass derived biochar which is reported in literature. Next one, ma'am. So this is the FTIR spectrum of the biochar and raw material. So these biochar possess different functional groups. Next one, ma'am. So this is the XPS analysis of the raw material and the biochar. And this carbon spectrum of the biochar shows the carbon singly bonded to carbon in carbonyl group, carbon singly bonded to oxygen, and C is double bond C. And similarly, the oxygen spectrum of the biochar shows the oxygen singly bonded to carbon and oxygen singly, double oxygen in carbonyl group. Next one, ma'am. So based on this characterization studies, this raw material can be a suitable precursor to prepare the high surface area and mesoporous carbon. So in the context of material development, the preparation method adopted in this study and the raw material selected in this study is found to be effective. So next, the prepared biochar is applied for the removal of the basic grade 29, which is the cationic dye from aqueous solution. Next one, ma'am. So this shows the the lambda max for this basic grade 29 is found to be 512 nanometer, and from the pH from 2 to 10 there is no change in the lambda max value. This lambda max value can be used to calculate the concentration of the dye in the solution, and which is strongly dependent on the pH.
Please make it fast, madam. Already 6 minutes over, so please make it fast. Finish up within 1 minute. Okay. Okay. Next one, ma'am. Next slide. And adsorbent dosage. So when we increase the dosage, the percentage also increases. So we fix the 50 mg as the adsorbent dosage. And next one, ma'am.
An effect of pH. So the optimum pH for this study is found to be acidic, that is pH from 2 to 3. Next one, ma'am. Effect of initial dye concentration in contact time. This absorption occurs fastly at higher initial dye concentration, and equilibrium can be reached easily. That is within 12 minutes, the equilibrium is reached for the absorption process. Next one, ma'am. And usually when we increase the temperature, there is no significant changes is absorbed. So the room temperature is fixed for the optimum temperature. Next one, ma'am, for dye removal. So absorption kinetics, pseudo first order, second order, and intraparticle diffusion model. So based on the R square value, pseudo second order model is found to be the a suitable model to describe the absorption kinetics. And the next one, ma'am. So Langmuir, Freundlich, and DR isotherm models have been employed to describe the absorption isotherm. And based on the R square value, Freundlich model is found to be fit to describe the absorption isotherm. Next one, ma'am. And based on the DR model, the calculated E value is less than 8 kilojoule per mole, so which indicates the absorption is species option. And the Freundlich constant N is found to be between less than 1, so which indicates the favorable absorption process. Next one, ma'am. And thermodynamic studies, so which are the component which helps to predict the absorption mechanism. And next one, ma'am. So based on the thermodynamic studies, that is the calculated thermodynamic parameter shows that the delta G value is negative, which indicates a spontaneous process, and the negative delta H value indicates the exothermic process, and the positive delta S value indicates increased degree of freedom of ions in the solution. So to summarize, the absorption is favored at acidic pH, and equilibrium can be reached rapidly within 12 minutes, and the maximum quantity according to the Langmuir isotherm model is 90 milligram per gram. Removal is achieved. And next one, ma'am. So the absorption process occurs spontaneously, exothermic, and with increased randomness. So the biochar, which is prepared from the agricultural waste material, can be used as the effective adsorbent for the removal of dyes from aqueous solution. Thank you, ma'am.
So congratulations, madam, for your nice presentation and nice work. Any question, clarification from the audience? Any clarification from the audience, please? Okay. First, I shall raise a few of the doubts, then the audience can also interact. What type of adsorption, madam, it is? Whether it is physics option or chemistry option?
Physics option, sir. Physics option.
Physics option.
I need to more study on this work, sir. This is my preliminary part. So after this is physics option, sir.
Oh,
Not
physics
detailed.
option means, but you don't have any effect of temperature. Is it so in physics?
Because at
You
room
said
temperature,
no effect of temperature. So it is not the case for normal physics option.
okay, sir.
If it is physics option, definitely temperature will have a role.
Yeah, yes, sir. Yes, sir. Maybe some other mechanism may play, sir, in the absorption process.
No, broadly you can speak physics option or chemistry option or mixture, right? But temperature plays a major role in deciding that also.
Sir, am I audible?
Yeah, it is audible. It is audible.
Okay, sir.
Audible.
Okay, sir.
What is the role of pores in this activated carbon? Or how do you say a carbon is activated carbon? Your carbon is, how do you test that whether the carbon is activated or not?
Sir, this is actually not the activated carbon. This is the biochar because I didn't activate it. Just I have taken the material and pyrolized. That's it, sir. I didn't activate it.
Okay, you have done the pyrolysis. Okay.
Only pyrolysis process up to this.
Okay. And you said in IR OH peak. Okay. How do you get OH peak? What's the source of OH? IR spectrum, you have shown OH peak. What's the source of?
The raw material is a cellulosic material, sir. Actually, it's a wood sawdust. So the OH may results from that cellulosic material.
Okay, madam. Okay. Thank you. All the best.
Okay, thank you, sir. Thank you.
Nice presentation. Thank you. Okay. No question from audience. Then we'll go to the next presentation.
Thank you, sir. The next oral presenter is number 16, is Sudha Parimala, on the topic facile synthesis of sulfonated graphene oxide from fructose for the degradation of organic dyes.
Good afternoon. Can I start?
Yeah, please start, madam. Please start.
Good afternoon, sir. Thank you very much for the organizers, and also I thank from my own institution and also my sponsor for the project, TNSEST, Government of Tamil Nadu. I just would like to sum up very shortly my work. Can we go to the next slide? Yeah. So actually, the very simple approach we have adopted, for which the reports are available to a very less extent. And this is our preliminary screening as far as our applications are concerned. We focus more on the fundamental approach to the synthesis of graphene oxide and its functionalization with the non-metal atoms, especially the sulfur atoms, for which many work has not been reported so far. So our approach, we started with a very simple monosaccharide of fructose. And as we have told, there is a need for efficient process which requires lower temperature processing as far as the processing. The temperature required also should be very less. That is what our first priority, because we quenched to almost 5 hours. And so far, the reports available are running to 22 hours and so on. This is our first approach. The second one is how to find out, basically, where the atoms, especially the sulfur and the oxygen atoms, which are competing with each other in terms of size as well as somewhat to a greater extent in size as well as a lower extent in terms of electronegativity. So we also did the characterization, and we were able to conclude upon the fundamental aspect of where the sulfur atoms are getting functionalized, whether they are impregnated on the basal planes of the graphenic framework or on the sides, so that if it is on the sides, the applications are tremendous. So this is the way we went. So the relevance is, please next slide. Relevance is have tremendous, as we know, it is GBNs, that is the graphene based nanomaterials. They have got tremendous applications, and we focused on the functionalized graphene in terms of oxygen as well as sulfur. So the inadequate results are obtained, and the present study explores a simple efficient process to prepare a 2D carbon framework with the heteroatoms of oxygen as well as sulfur. Next, please. Yeah, to optimize the experimental conditions of the graphene oxide using this fructose as a precursor by a very simple hydrothermal process, whereby we introduced these atoms and we screened. Actually, it was really a preliminary screening for where the reports are not at all available, right? For the catalytic activity of the discoloring.
So please go, make it fast because you are consuming a lot of time.
Okay. Yes, sir. Next slide. Next slide. Yes, sir. So the scheme of preparation is very simple. And then we had actually what is called as the post modification. As we were able to confirm the presence of graphene oxide, then we were able to impregnate sulfur by means of just post modification with sulfuric acid. Next slide, please. Yeah, that we were able to find out that the solubility definitely varied, which also gave a clue about the introduction of the sulfur. Yes, next. Yeah, the FTIR spectrum, definitely we have now presented the FTIR of the precursor, that is even before adding the sulfuric acid and after sulfuric acid. So we were able to confirm the presence of all the atoms. Next one. Next, please. Next slide, please. Yeah, the micro-Raman spectrum, the previous one, the micro-Raman spectrum. Previous slide, please. Yeah, the micro-Raman spectrum was really helpful because based upon the ID and the ID by IG ratio, we were able to very confident that the sulfur has been impregnated and the number in the decrease in the number of the graphenic layers. So the layer structure was disturbed. The next one. Then the results of the PXRT were also correlative with that of the micro-Raman because of the decrease in the D-spacing value. Therefore, which also gave a clue, right? The functional groups are present at the edges, more at the edges than in the planes of the graphene layers. Next one, please. Next. Yeah, the SEM also, the SEM images, the micro, it was able to give the morphological view that the spherical aggregates were there, and sulfur we were able to spot out on the surface, and the elemental composition were also given by the EDAX values, and the C/O ratio has tremendously increased, also indicating that it is more the functionalized graphene in terms of oxygen and sulfur. Next slide, please. Next slide, please. Yeah, see, this is what is a preliminary screening. We were able to find out the decoloration efficiency actually in the presence and absence. Actually, we wanted to find out whether it is the degradation was found to be in the more favored in the presence of light, UV light, or in the absence. So we wanted to find out the absorption capacity as well as the degradation capacity in terms of photochemical means. Yeah, but the introduction, we find that the introduction of the surface defect, that is the sulfur, has created more defects, which were also able to play a role in the degradation process. So many intermediate energy levels were created, which also play a very important role in the degradation of this. Yes, next slide, please. Next. So the summary and the conclusion is, yes, we were able to functionalize with an electronegative non-metal atoms from a ketose. Okay, it is a very simple, efficient process. After all, we introduced the autoclave for 5 hours, right? And maximum temperature we reached was only 180 degrees centigrade. So the microstructure and the morphology, they confirmed the occupancy, and the results were also suggestive of the surface defects, which were favorable for any other application, including the catalytic as well as the photo degradation. So seeing the study will ultimately provide cues for the industrial wastewater management, because we are having a plan to optimize and then go for the other dyes also. Next slide, please. Next slide, please. Next, yeah. The next, please, path forward. Yes, to optimize the experimental conditions and fix the kinetics of the deglarization, because this is a preliminary screening, and we would like to optimize the experimental condition for different chlorophenols also. It is only a dye. So we wanted to explore for the other chlorophenols which are more toxic, and then which are most, which are being left after the usage of many disinfectants. Next one, please. Yes, we would like to acknowledge the Tamil Nadu State Council for Science and Technology for sponsoring our project, and then our own institution, the Department of Chemistry at the Raj College for Women. So any questions? This is my presentation. I will try to conclude my presentation. Thank you.
Congratulations, Usha, for your nice presentation and nice work.
Yes, thank you.
Any question or queries from the audience side? Please. Please ask 1 or 2 questions.
Yes, good evening, sir. This is Dr. Andal.
Yeah, please, madam. Please go ahead.
Yes, I have a question. Usha, madam?
Sudha, I am Sudha.
Sudha, okay. Actually, you were mentioning about chlorophenols in your final slide now.
Yeah.
Have you started some basic work regarding that?
Yes, madam. We have started, and they are giving a very, favorable results.
Okay.
But
so what are the conditions? What are the conditions you are suggesting for that?
Actually, we find that acidic conditions are more favorable than the neutral conditions. We have started off the process, but we have not optimized.
Okay.
Yeah.
Thank you. That's a good piece of work.
Yeah, thank you.
Madam, I have one clarification. Why you go for fructose instead of glucose? What is
we have already. Yeah, we have already exhausted the exploration of glucose as a precursor, and we have published very good Scopus index journal. It's not that we have published, but they have given a convincing reply. But we wanted to see whether there is what type of role played by a ketose and aldose as a precursor. After all, they are isomerizable, and we all know
Do you think a major difference would be there? Are you
yes, sir.
Are you expecting
Yes,
a
sir.
major difference between ketones
Yes.
and?
Yeah, that is what we have found out, that definitely the approach is same, but the doping, actually the
Is there any
functionalization.
change in the morphology?
Yes, sir, definitely. And this is found to be more there. We were able to find a better, the graphenic framework was very much retained. But here somewhat there is a discontinuity. This I have found. And also the doping of the sulfur atoms is enhanced in this compared to the glucose when we use glucose as a precursor.
Any reason for that, madam? Doping of
That is what we are finding. Actually, that should be, I think, the chemical route also plays an important role. That is the intermediate stage plays an important role. That is what we are going to. I know we have proposed a mechanism also. So definitely
Then you have to check the reproducibility of your results also.
yes, sir. Yeah. This we have really reproduced the results with respect to glucose as a precursor. So it has given us confidence that how we can go about this, and then we can definitely compare both the processes and the efficiency also.
Thank you, madam. Thank you for your.
Thank you, sir.
Very nice work and presentation. Thank you, madam.
Yes, sir. Thank you, sir. Thank you very much.
We'll go
Thank
to
you,
the
ma'am.
next.
Yeah, thank you.
The next oral presentation is by number 23, Dr. S. Berbat Mary, on the topic effect of annealing and sintering on thermoelectric properties of surfactant assisted calcium cobalt oxide nanoparticles. Presenter, you can start sharing your screen.
Ma'am, good afternoon.
Yes, ma'am, we can hear you.
Good afternoon, ma'am. Am I audible?
You are audible. You can go ahead, please, madam. Please go ahead.
Sir, can you view my screen, sir?
Yeah.
Yes. Yeah. Good afternoon, Unada. I'm Dr. S. Berbat Mary, Assistant Professor in Physics, MEM School of Engineering. I thank the organizers for this wonderful opportunity to present my research work. I have done this work under the guidance of Dr. A. Leo Rajesh, St. Joseph's College, Trichy, and the topic of my presentation is effect of annealing and sintering on thermoelectric properties of surfactant-assisted calcium cobalt oxide nanoparticles. Plan of my presentation is introduction, experimental procedure, results and discussion, and summary. Introduction. thermoelectric technology which converts the irrecoverable heat energy
Yeah, please
into...
skip the introduction, madam. Better. There's already, yeah, better you go to the results.
Yes, sir. Yes, sir. Right. Actually, thermoelectric materials which converts the waste heat into electricity. For thermoelectric materials, it should have large Seebeck coefficient, high electrical conductivity, and low thermal conductivity. I have concentrated on reducing the thermal conductivity of the materials what I have chosen by means of sintering and annealing. I have chosen salt gel hydrothermal method to produce nanoparticles. My results and discussion are, you can see the structural analysis of calcium cobalt oxide nanoparticles at various annealing temperatures. I have chosen 800 to 1000 degrees centigrade in steps of 50 degrees. In that, I have observed that monoclinic subsystem is observed, and citric acid and PVP I have chosen for surfactants, which does not have any impact on the crystal structure. That shows from the there is no secondary peaks. And at lower annealing temperatures, low crystalline materials with a large size of nanoparticles are observed. At the reverse of that, at higher temperatures, agglomerated samples are observed. So the optimized temperature, what I have observed is 950 degrees centigrade, and the average particle size increases with increasing the temperature of annealing. It is from 32 to 57 nanometers, and the observed particle size for the optimized sample is 42 nanometers. And this is the morphological analysis of calcium cobalt oxide with various temperatures, annealing temperatures. In the same case, at lower temperatures, foamy structure is observed, which has high surface area, but that reduces the high electrical conductivity also. But electrical conductivity should not be reduced. For that, I have chosen the surfactants like capping agent as PVP, that is polyvinyl pyrrolidine, and citric acid as chelating agent. At lower temperatures, foamy structure is observed. At higher temperature, that is about 950 degrees, in case of 1000 degrees centigrade, agglomeration of particles observed. And homogeneously dispersed particles with connected network is observed at 950 degrees centigrade. And the EDAX spectrum is also shown in the figure. And this is structural analysis of optimized calcium cobalt oxide nanoparticles, that is that annealing temperature is maintained at 950 degrees centigrade. For that, monoclinic system is observed, and the lattice parameters are 4.8 is A and 4.5 is B1, B2 is 2.8 and C is 1.08 angstrom. There are no secondary peaks, which indicates that citric acid and PVP does not affect the structure of the crystal. And modes that from the Raman analysis, I have observed that modes at lower frequencies, that is heavier metals of calcium and cobalt presence, and at modes of higher frequencies, lower atomic power atoms like oxygen is observed. And this is morphological analysis of optimized calcium cobalt oxide nanoparticles. That annealed sample at 950 degrees is once again sintered at 800 degrees centigrade in order to get a dense sample, because calcium cobalt oxide is it's a powder sample and foamy sample. It is not a dense material. In order to get a dense material, I have sintered the sample at 800 degrees centigrade, and I have obtained the dense sample also. The samples are once again made into dye as the structure is nanoflakes. Inclusion of oxygen is reduced, that improves the thermal power of the material. And the EDAX spectrum also shown that cationic ratio is 1:1. And thermoelectric analysis of optimized calcium cobalt oxide nanoparticles. In the first image, we can see absolute Seebeck coefficient value, that is positive. It shows that P-type material, that is calcium cobalt oxide material, is a P-type material. Here, holes are major charge carriers. And S value increases with increasing temperature. I have obtained the physical parameter values from room temperature to 600 degrees centigrade. In that range, a large Seebeck coefficient value is keep on increasing. It is due to metallic behavior of the metal. And significant increase at 100 degrees centigrade, that is from second image, you can see that it is due to metallic insulator increasing transition temperature. At 100 degrees centigrade, we can see a peak, which is due to metallic insulator transition temperature. And third one, it is a activation energy graph. It shows small Polaron model is suitable for this material in this range, that is room temperature to 600 degrees centigrade. And power factor is influenced by Seebeck coefficient value. That is, power factor values keep on increasing with this range. And this is my summary. I have calcium cobalt oxide nanoparticles were synthesized by sol-gel hydrothermal method, and samples were annealed at different temperatures and sintered for the thermoelectric application. The sintered sample showed high density with monoclinic misfit layer structure at 950 degrees centigrade. And the structure of the crystal is a rod-like structure. Absolute Seebeck coefficient value increased with increasing temperature and decreased electrical resistivity due to metallic insulator transition at 380 Kelvin. Power factor value increased while increasing the temperature from ambient to 600 degrees centigrade. This result shows that calcium cobalt oxide material is a significant material for P-type thermoelectric applications. Thank you all. Questions, sir?
Thank you, madam. Thank you for your nice presentation and also your interesting work. Any clarification from the audience side? Please. Then, why, madam, why agglomeration? How do you relate the agglomeration and the temperature?
So, I have to get a non-agglomerated samples.
No,
While increasing the temperature,
yeah, my question is why the agglomeration takes place at high temperature?
it is due to increased size. Particle size increases and get agglomerated, sir.
Yeah, of course, particle size increases because of agglomeration. Why it happens? That's my question. Can you stop with the surfactant or capping agent? When you change the capping agent, can you stop?
Yes, I have tried with two surfactants like capping agent as polyvinyl pyrrolidine and citric acid as a chelating agent also. And also above above 950, actually 950 degrees itself, it starts agglomerating.
Okay.
It's due to might be kinetics. Fast growth. I think so, sir.
Fast growth.
Okay. Yes, sir.
Will the morphology is affected because of the capping agent, or any role, or both the capping agent gives the same morphology?
I have taken the SEM analysis after taking this annealing only, sir.
Okay. Okay. Okay, madam. Thank you. Thank you very much for your.
Thank you, sir. Thank you very much. I thank the organizing committee and the institute also, sir.
The fourth presenter of the session is OP number 52, Rajavel Velayudham, on the topic electrodeposition of vanadium pentoxide on carbon fiber cloth as a binder-free electrode for high-performance asymmetric superconductor. Sir, you can start sharing your screen. Sir, you can start sharing your screen, sir. Velayudham, sir.
சரி உச்சா வரீங்களா பாத்ரூம் போலாம் வரீங்களா நான் அம்மா உச்சா போயிட்டு வந்துட்டா
கிளிக் பண்ணுங்க சார்.
Sir, you can unmute your mic.
Good afternoon, ma'am. Hello. Hello. Can I audible?
Yes, sir. You're audible and your screen is also visible. You can start.
Good afternoon to everyone. My research topic is electrodeposition of vanadium pentoxide on carbon fiber cloth as a binder-free electrode for high-performance asymmetric supercapacitors. This is my outline of an research work. So just I started with an introduction point, then electrodeposition of binder-free vanadium pentoxide then experimental work and validation, then applications. I start with the introduction points. Supercapacitors is an energy storage device. It can store the energy as quick and release the energy as quick. So it consists of porous electrodes, electrolyte, current collector, and a separator. Separator is an ion permeable membrane. When the potential is applied, the ions in the electrolyte moves towards the opposite polarity and forms a double layer. It stores the energy. This is the introduction part of supercapacitors. Then advantage of supercapacitor is the fast charging and discharging, but main disadvantage is low energy density as compared to power density. So we overcome the low energy density, the electrode material should be the high surface area, low charge transfer resistance, and less ion diffusion resistance. So from this perspective, to reduce the resistive behavior, so I'm going to the electrode deposition techniques to fabricate electrode materials. Let's start with the carbon fiber cloth as a substrate materials, then go for electrode depositions. So I started with precursor radium oxide, so 10 minutes and 20 minutes and 30 minutes and 40 minutes. Let's start with the physicochemical characterization. From the XRD analysis, so let's 30 minutes and 40 minutes, the phase was formed V2O5, but in case of 40 minutes, the carbon peak was intensity of completely reduced. So from the conformations, phase was formed is V2O5 and structure orthorhombic structure. The morphology effects of electrode deposition of materials is just 10 minutes is just started to deposit. So 20 and started to VO2 phase is formed. Then 30 is goodly the rope-like structures is formed on the carbon fiber cloth. But in case of 40 minutes, that agglomeration of materials over the carbon fiber cloth. Let's just conclude with the electrochemical characterizations of electrode deposited materials. Let's start with the cyclic voltammetry, and this is the comparative graph of carbon bare carbon fiber cloth, 10 minutes, 20 minutes, and 30 minutes, and 40 minutes. This is a CV diagram, but in 30 and 40 are nearest equal to each other. So I confirmed with then I further characterization with the charge discharge cycles. 30 and 40 are nearest discharge time. So nearest discharge time. Then I conclude with the aerial capacitance, how much capacity it can hold. So nearestly 30 minutes shows 354 millifarad per centimeter square. But in case of 40, it shows higher, but rate capability suddenly decreased. That's why I conclude that 30 minutes is showing a good electrochemical behaviors or aerial electrochemical energy storage materials. So then I further concluded with the resistive behavior EAS. Then 30 minutes shows very less as compared to other electrode deposited materials. Then I sideways prepared for negative as an activated carbon and studied the CV and GCD and specific capacitance. From the positive electrode and negative electrode based upon the mass balance equation, I prepared asymmetric supercapacitors. This is the diagram. So from this graph, you can conclude the energy density and power density around 17.7 watt-hour per kg, and also it shows very capacity retention around 90% or even after 10,000 cycles. So then, since it is a binder fee, my research was towards the flexible type asymmetric supercapacitors. Is in a positive and negative electrodes. Then I studied CV and GCD. From this device, I can conclude that 13.3 watt-hour per kg energy density was achieved. But in commercially, it was around, for in case of asymmetric, it around 10 kg. So in this research work, I achieved improved energy density. Sorry. This is an application point. Slide. This is an applications. Supercapacitors are used in cellular power electronics and UPS devices. and also it is used in industrial lasers and medical equipments. And supercapacitors are used in electric vehicles for low level loading to extend the life of batteries. And also it can be used for VCR, CD players, electronic toys and security system, computer scanners, smoke detectors, microwaves, and coffee makers. Thank you for your attention. Thank you very much. Any queries?
Yeah, so well, so nice presentation and a nice work.
Thank you, sir.
Yeah. Any clarifications? And what is the real-time application of your supercapacitor?
That real-time applications are used
Of your
for
capacity.
LED. Right now, I checked with LED applications. It
Okay.
for research work, I checked with the LED application. If I go for the parallel type with making a coin cell type as a supercapacitors and make an assembly with series and parallel, it will go for a real-time application for large portable devices.
Okay. Okay. Very nice, and congratulations and best wishes to you.
Yeah.
And you are working on the very frontier area of research. Thank you. Thank you
sir.
for your presentation.
Thank you, sir. Thank you.
Thank you, sir. The fifth presenter of the session is OP number 53 on the topic post-synthetic annealing of zeolitic imidazolate framework 6-7 for high-performance hybrid supercapacitors. Sir, you can start sharing your screen. Velayudham, sir, you can stop presenting so that the next presenter can start. OP52 can stop presenting so that the next presenter will start. Can stop presenting. Sir, you can stop presenting so that the next presenter will start.
Good evening, everyone. Myself, Kale Amol Marutrao, and I am pursuing my PhD degree with Professor Byung-Chul Kim, the Department of Printed Electronics Engineering, Electromaterial Science Lab, Suncheon, South Korea. Hello, can I audible?
Yeah, you are audible. Please go ahead. Please go ahead.
Okay, thank you, sir. Next. Contents, I will go through the introduction, synthetic method, physiochemical characterization, electrochemical characterization, and finally, conclusion. Introduction. Nowadays, supercapacitor gaining a lot of attention from the scientific community due to its some advantages like fast charge discharge, high power density, long term cyclic stability. But the only one disadvantage with the supercapacitor is they having low energy density. So to overcome this problem of low energy density, a lot of people trying to enhance the energy density, like using some metal oxides, or using some different type of bimetallic MOFs, or the hybrids by making the hybrid supercapacitor. Generally, hybrid supercapacitors are made up of positive electrode that is mainly based on the porous metal oxides, and the negative electrode that is the cathode is based on the porous carbon material electrolyte and the separator. This is the synthetic method. We simply synthesize the ZiF67 by using the cobalt as a metal precursor and the 2-methyl imidazole as a organic ligand. By simple precipitation method, we synthesize, and the after by doing the post synthetic annealing, we prepared the 3 different types of ZiF67 samples by using the annealing temperature 200 degrees Celsius, 300 degrees Celsius, and the 400 degrees Celsius. This is the now we will go through the physiochemical characterization. First of all, showing the TGA data of the ZiF67 sample, we can show clearly see that the first weight loss of 7.48% around 140 to 220 degrees Celsius is mainly due to the chemisorbed water molecules, and the second weight loss of 48.18% from the from the 260 degrees Celsius up to 410 degrees Celsius is mainly due to the removal of the unbounded organic ligands, that is 2-methyl imidazole. Secondly, we characterize the all samples by the XRD analysis. But there is no big difference in the XRD pattern of the post-annealed samples. They are showing the similar pattern as like the parent ZiF67. So after that, to study the specific surface area, we did the BET analysis for all 4 samples. So the sample prepared at the 300 degrees Celsius, that is ZiF67 at 300, showing excellent specific surface area as compared to the other sample, showing 1,879 meters square per gram, and the pore size is the average pore size is the 1.7 nanometer. This is the then we did the FSM analysis to study the morphology of the synthesized sample. We can clearly see that bare ZiF67 showing the unclear boundaries, but while increasing the annealing temperature, we can say the edges of the dodecahedral ZiF67 MOF seen clearly. The sample treated at 300 degrees Celsius is showing the proper dodecahedral morphology, but the sample annealed at the 400 degrees Celsius 400 degrees Celsius is the showing the infused, they are infused in each other due to the decomposition of the organic linker 2-methyl imidazole. Further we did the EDUX analysis to confirm the element present in the ZiF67. From the EDUX, we confirm that the carbon, nitrogen, and oxygen and the cobalt are present in the ZiF67. Furthermore, we did the TEM analysis for the ZiF67 300 sample. From 10 analysis, we can see that it's showing a microporous structure with a size of 200 nanometer. particle size is 200 nanometer. So furthermore, we did the electrochemical characterizations for a 3 electrode system. We compared all 4 samples. We can see that the ZIF 67300 sample CV is showing a large CV area as compared to others, and same as like CV in GCD. ZIF 67 sample showing the more discharge time as compared to the other samples. So ZIF 67 samples exhibit excellent electrochemical properties as compared to other samples. It's showing the specific capacity of 349 coulomb per gram, which is far better than the other three samples. Also, we check the resistive behavior of the all samples by doing the AIS analysis. From figure, we can see that in pink color, ZIF 67300 sample showing the less solution resistance, as well as less charge transfer resistance and less Warburg resistance as compared to the other 3 samples. Also, we we did the cyclic stability for the 3 electrode system for the ZIF 67300 electrode. We did up to 500 cycles, and it retains its initial capacity of 94% after the.
Tell Amol, please go to your conclusion part, summary part. So already we are running out of time. Please.
Yeah, we assembled hybrid supercapacitor device by using the ZIF 67300 as a positive electrode and the activated carbon as a negative electrode, and we we tested it for a real time application. It's blowing the ZIF 67. ZIF 67 file. Also, the discharge voltage it given is 2.95 volt, and also it blow the different color of LED like blue, red, and green. Green. It's because of the high power density of hybrid supercapacitor. That is around 30 watt hour per kg. Conclusion: by post-synthetic treatment technique, we can enhance the physical as well as chemical properties of MOF structure for superior application in energy storage device. We successfully synthesized the ZIF 673 300 material by post-synthetic treatment of ZIF 67 with microporous size and the high specific surface area with enhanced electrochemical properties. Thus, this post-synthetic annealing strategy will be open up a new platform for the developing MOF architecture for high performance supercapacitor. Thank you.
Thank you and congratulations, Khal Amol. It's a very excellent work and presentation.
Thank you, Professor.
Yeah. Any queries from the audience side? No queries. Then, what are the advantages of hybrid supercapacitors over the conventional one?
Actually, Professor, hybrid supercapacitor, they are prepared from 2 different types of electrodes. That is, one is a positive electrode that is based on the metal oxides or the metal oxide based materials, and the that anode material, that negative electrode, is generally based on porous carbon. So hybrid capacitor is the mixture of EDLC and the pseudo capacitance. EDLC, that is electric double layer capacitance, which comes from the only porous carbon material, shows the EDLC nature, while metal oxides they showing some pseudo capacitance. Why pseudo capacitance? Means in the electrode which are based on the metal oxides, there are some redox reaction. There are some redox reaction on the surface of the materials, but in EDLC they just absorb the ion. They absorb the ions from the electrolytes and store the energy. But in this is the, and by mixing both these electrodes as a EDLC and pseudo capacitance, that is hybrid capacitance. It shows the more energy density as well as power density compared to the pure pseudo capacitors and the EDLC capacitors. This is the advantage.
Thank you. Thank you very much. All the best. All the best.
Thank you, sir. The last presenter of the session is OP number 54 on the topic BNGQD on surface modified copper mesh for the determination of dopamine and epinephrine. Presenting your screen.
1 minute, ma'am. 1 minute. Dr. Vijay Shankar, have you joined, sir?
Yes, madam. I'm here.
Okay, sir. Thank you, sir.
Thank you,
sir.
sir.
Few more minutes, sir.
We were trying to contact
We're
you,
trying
sir.
to-
Maybe- Thank you, sir.
We can start in few more minutes, sir. Sorry for the delay, sir. Few more minutes, sir.
Hello. Yes, good evening, madam.
Sir, we'll start in few more minutes, sir, after this presentation is over.
Yes, ma'am. Am I here? Hello. I'm Tonday, ma'am.
Hello, sir. Yes, sir. You're audible, sir.
Can I start, ma'am?
Yeah, Tondeman, please limit your presentation to 3 minutes. Please
Yes, sir.
finish off by 3 minutes.
Yes, sir. Thank you, sir. Thank you, sir. Myself, Tondeman, from the same lab, before presented my friend. And today, good evening, and I'm talking about just brief about my work regarding with biosensor. So just skip a brief introduction about biosensor. Here I'm focusing about that we have each section, especially the biosector, transducer, electronics. Here I'm focusing about the transducer part, and in the transducer I'm using a technique of electrochemical technique, that is enhancing the biosignal to electrical signal with the help of electrochemical mechanism. So here are the biosensor, various biosensor we having in our application commercially. Especially we have the glucose sensor is the most successful commercial biosensor. And also why I'm focusing on the neurotransmitter. With neurotransmitter is still in the pending in the research part. Yes, ma'am. So that I am focusing on the neurotransmitter. It especially it having more what it affect the CNS system. So here my work is according with
எத்தனை presentation இருக்குப்பா?
ma'am.
This is
Hello. Yes, sorry for the disturbance. Here I'm working on that copper mesh electrode. Why I'm focusing the electrode part? Electrode is most cheap. We can easily the commercial biosensor glucose sensor having that because of the electrode, it's a screen printed electrode. That's why its cost is reduced. So we can focus on the electrode. We can achieve from research to commercialization. So here I'm copper mesh basically it's easily react to the environment and it oxidates. So I will overcome and I make the copper mesh as a stable electrode with the help of GQD, graphene quantum dot, and conducting polymer. Here I worked on amperometric detection of dopamine and epinephrine, under the sensitivity of the dopamine I achieved 0.76 microampere per micromolar centimeter area. So how I did, this is the fabrication of surface modified copper mesh electrode. Here I am using a simple technique to fabricate. The first one is I convert a copper mesh to copper oxide, and then GQD was synthesis by hydrothermal technique, and both with the help of electropolymerization I composite with the GQD and the P dot over the copper electrode. Material characterization from the UV I confirm that from the GQD nature, and from the XRD I confirm the copper oxide, and EXPS I confirm the presence of the elements. Here the same image, the copper oxide shows the fiber-like structure, and the electrochemical studies, from the electrochemical studies, the left hand part I present that my electrode is in a Cauchy reversible state, and the EAS gives that nitrogen boron dope, it enhances the conductivity, and the right hand side I give that dopamine and the E prime, that the 0.22 volt amperometric voltage I sense the dopamine, and 0.28 volt using the volt, I sense the E prime from the sensitivity. The limit of detection of the dopamine from boron nitrogen doped GQD, I got around 0.270 micromolar, and dopamine, and E prime I got 0.084 micromolar. From the conclusion, I give my electrode as being well stable at that. These electrochemical studies I did in PS7 with PBS solution, but and I achieved the electrode stability comparison table I give, and I achieved this research gives the motivation of this research just focusing on the cheap electrode. So this is what I am achieving, sir. Thank you.
Thank you. Thank you.
I finished my presentation.
Yeah, thank you, Thanaman, for your nice presentation and any queries from the audience side? If no queries, we will close the session.
On behalf of Department of Chemistry of PSGR Krishnamal College for Women, I thank Dr. S. Ponnusamy, Associate Professor and Head, Government Arts College, Coimbatore, for chairing the session. Thank you, sir.
Welcome, madam. Welcome. Thank you. Once again, I thank you, the organizers, for giving me an opportunity to chair the session. Thank you.
Welcome back, everyone. After the best expression of your ideas in the oral presentation, we are here for the invited talk 6. With all our renewed energies post-lunch, now we unite to refresh our knowledge. May I now request Dr. N. Anushya, Assistant Professor, Department of Chemistry, PSGR Krishnamal College for Women, to introduce the speaker, Dr. Vijay Shankar Ashokan, sir.
A very good afternoon to one and all gathered here. It's my pleasure to introduce Dr. Vijay Shankar Ashokan, researcher, Chalmers University of Technology, Gothenburg, Sweden. He did his doctoral degree at University of Bergen, Norway, and postdoctoral degree at Zhejiang University, China. His research activities are focused to provide a solution to the selection of materials and its performance in energy production, engines, and industrial processes. His research experience also includes carbon nanostructures, two-dimensional materials, and electron microscopy. Dr. Ashokan has published 31 research articles in peer-reviewed scientific journals and presented his research work in more than 22 international conferences held at Norway, Sweden, Denmark, Portugal, Italy, China, India, Sri Lanka, and USA. He has delivered 35 scientific lectures in various Indian academic institutions. SAR is a visiting lecturer to University of Jaffna, Sri Lanka through Indo-Norwegian Sri Lanka collaborative project. He was also an organizing committee member of 2 international conferences held at Coimbatore Institute of Technology, Coimbatore, India through Indo-Norway collaboration research. To his credit, SAR has published 4 books and more than 50 articles in Tamil in varied topics like environmental policies, renewable energy policies of Europe, Tamil Nadu politics, mother tongue education, European and Nordic education system, Tamil history, Indian education, and travel literature. In addition to his scientific activities, Dr. Vijay Ashokan is also active in many social activities. In Norway, he served as a Tamil teacher in Anai Bhupadi Tamil Culture Center and coordinator of Tamil School, Sweden. SAR is serving as one of the coordinators in European Periyar Ambedkar Comrades Federation Chairman in Nordic Forum for Science and Technology Association, Sweden. SAR has been active organizer in many international conferences. To list a few: Nordic Education Conference, Asian Tamil Education Conference, World Tamil Education Conference. We are extremely fortunate to have such an eminent and vibrant researcher amongst us today to share his expertise on solar cell devices. Sir, I request you to kindly take over the session.
Yeah. Thank you, ma'am. Let's update ourselves on recent advances in perovskite solar cell devices with SAR's expertise. Over to speaker.
Yeah, thank you, madam. Thank you for a nice introduction. And am I audible? And is the screen is visible?
Yes, sir, you're audible and the screen is visible.
Oh, yeah, that's good. Okay, thanks again for a nice introduction and nice organization of this conference organizers. Today, I'm going to share our few experiences on perovskite material. So my title is around recent advances in perovskite material-based solar cell devices. I am Dr. Vijay Shankar. Now I'm sitting in Nordic country, basically Sweden, and Gothenburg. That's a city of Volvo cars and Volvo industries. So it's a headquarter for Volvo. You might have heard about the famous Volvo company everywhere. Right. Apart from this, if I just wanted to introduce myself, like I have wide experience, like basically among the Coimbatore people, I'm very near to heart, I can say. I did my bachelor's in Coimbatore Institute of Technology and master's in PhD College of Technology, MSc in Material Science. Then I did some project in Indira Gandhi Atomic Research Center and in Indian Institute of Sciences, Bangalore. Then I moved to University of Bergen, Norway to start my PhD in 2008. Part of my PhD was also done at University of Oslo, Norway. Then I did my postdoc in Zhejiang University, and I continued my second postdoc in Chalmers University. Now I am continuing as a researcher since 2020 January in same Chalmers University. In our Chalmers, we are basically we are a high temperature corrosion center people. We are a competence center in Sweden's energy policy or Sweden's energy agencies. So our major funding agency is the Sweden Energy Agency, and also 18 partner companies. Basically, they are working with renewable energy production, mainly biomass industries and the solid oxide fuel cell groups. So we are a solution provider to them to mitigate the corrosion issues, what they are encountering during the production process of, again, energy production process, when there are possibility for a high temperature region, and even in solid oxide fuel cells, you have interconnects, which is made of solid stainless steels. In high temperature, even with a corrosive environment, there are possibility for more corrosions, which limit the lifetime of energy unit, right? So we are one among the research group in Nordic or in Europe, we can say, who are working closely with all these energy companies solving high temperature corrosion issues. We have, like Sweden's energy unit is our major partner, and we also have Ceres Power from UK. They are a solid oxide fuel cell company, and there are more energy and stainless steel companies in and around Sweden. With them, we are working very closely with all these issues. But there are also a few success stories in our high temperature corrosion center. We did very good service to the fuel cell market in Sweden. Our partnership with those companies, and like in reverse, those companies' partnership with us made them very success in their economy rate. That's the story, even which was popular in Sweden in 2014 to 2017, because we are declared as a well-functioning center of excellence that conducts high quality and internationally recognized generic research into high temperature corrosion. And our partner companies are very happy because of the sustainable energy production also continuing in a successful collaboration with us. But mainly, I am actually working with microscopy. So my part is completely a microscope. I am a microscopist. Even though I'm working in chemistry division now, I limit my service or limit my research within the microscopy. So I have a wide experience since Indian Institute of Science project period, which is in 2007. So almost 14 years, I am revolving around the microscopes, or even revolving around the world with microscopes. That's what I can say. I'm now operating almost all the microscopes in our Chalmers, and I'm fully equipped with all the, and even our division is fully equipped with all the needed equipments within the microscope part. So that's my story. And also I have a strong collaboration even within India and around the world, to name few my collaborative projects and publications or recently published together with Swansea University, UK, Exeter University, and Western Norway University, PSG College of Technology in Coimbatore, CIT, Madurai Kamaraj University, Pondicherry University, and there are a few publications from University of Jaffna, Sri Lanka, and of course from Zhejiang University, where I did my postdoc. So I have a collaboration network around the world. I have good publication rate together with them. Today, I'm going to present the perovskite research of our collaborative project that's mainly done through Indo-Norwegian collaboration project. So the partner universities are Western Norway University of Applied Sciences, University of Exeter, and CIT is a major collaborator of this Indo-Norwegian project. And recently, University of Jaffna also joined with us in that Indo-Norwegian collaboration. So this is the Indo-Norwegian collaboration team working in Physics Department, Coimbatore Institute of Technology. And today's major work is from the publication of Dr. Selvakumar, who recently defended his thesis, and he's doctor now, and also started his research associate position in University of Bergen, Norway this month. So he just joined Norway again. I think he's also in the meeting now. He will answer if there are any questions related to his project. Anyway, I will present and I will be here. Right, so this is our team. Professor Dayalan Velayuthapillai is a major partner from Indo-Norwegian project, and Professor Muthukumar Swamy may be well known among the Coimbatore academicians. And Dr. Gilan is here, and these are the project team. Right. So let me start with a topic. Before that, I just wanted to have a basic introduction to solar cells. There may be few students community or few students joined in the meeting. So I wanted to start from the beginning. So what are the photovoltaics? So photovoltaic system convert light energy directly into electricity, as we all know, and we have a simplest well-known power system. What we have in our hand is a small calculators. Yeah, PV, that's a photovoltaic represent one of the most promising means of energy production or energy circulation unit, which makes our standard of living like more sustainable without contributing to the global warming and pollution. That's a major advantages why we are moving into solar cell divisions. So nearly infinite supply of free energy through the solar cell and through the sun, which gives around 32 into 10 power 24 joules a year. So sun daily provides about 10,000 times more energy to the earth than we consume. So there is no radiation risk, no noise, no emission, and longer lifetime compared to other units. So that's a specialty or advantages of these solar cells. As we know, if you see on the right side, there's a, oh, sorry, where is the laser point? Just a minute. Yeah, okay. If you see the right side, this is the solar spectrum of solar radiations, and we are talking about visible radiations here, what we need for our energy productions. Right? So with this basic knowledge, there were solar cells since 1950s. We can call it as the first generation photovoltaic. There are more researchers from the Bell Laboratories, USA, in those period, and they have formed first generation photovoltaics, if I remember rightly, with like a single layer PN junction diode. That's a basic solar cell unit which was first constructed. So since then we can say it's a first generation, and all the photovoltaic cells which was formed later, which was come under first generation until the second generation was popped up. So before going into the deep knowledge of solar cells, if you just make understanding of how these solar cells are working from the knowledge of first generation photovoltaic, then it's very easy for us to get on moving on to other types of solar cells, and in particular with the perovskites. So here only photons with a sufficient energy can excite across the band gap. So the band gap is denoted as Eg here. So insufficiently energetic photon, which is less than those, will not be contributed to the photocurrent generation. So only which is more than those band gap value can generate an energetic excited charge carriers. So the remaining even will be wasted by thermalization process, right? So when you see the basic schematic of solar cells, it's very simple in the construction. You have a P-type silicon and N-type silicon, and there are interface layers, and the load is connected here, right? When the load is connected, the electron will be moved in one direction and the hole moves in another direction, which we know from our basic physics. So this is the basic idea we want to know before proceeding with other slides. So this is a simple construction, and just wanted to bring this to make understand how the solar cells are working on. Before moving into other details, I just wanted to bring this slide because this is more important when I'm talking about the results of solar cells or perovskite solar cells. I may use ISE or VSE values. So I just wanted to make sure everyone knows what this is, right? So the behavior of solar cell can be monitored by these values. The point at which the curve intersects the vertical axis is known as a short circuit condition, we can say, and that defines how the cell operates if the wire is connected between its terminals, like shorting it out, right? So the current flow here is known as a short circuit current. For an ideal solar cell at most moderate resistive loss mechanism, the short circuit current and the light generated current are identical, right? So therefore, the short circuit current is the largest current which may be drawn from the solar cell, for your understanding. Just remember this thing. That's the largest current which may be drawn from the solar cell. The point at which the curve intersects here in the horizontal axis is known as the open circuit condition or open circuit voltage. So we want to get from these conditions, we want to make a calculation of maximum power point. That's a power calculation from I into V, right? So all the solar cells are calculated based on these values. Even in depth, if you want to go, these are the notations which is given for all the open circuit voltage condition and short circuit current conditions. So these are the points to be remembered. Like as I said, P max, that's V and I max somewhere here. That's we want to know when we want to study the behavior of solar cells. So with this one, we can calculate fill factor. With this one, we will proceed to the photo conversion efficiency values. So those are the things which gives a meaningful results or meaningful understanding of your solar cell, what you are making. So with this one, I'm moving to other slide. Yeah. So we know how solar cell works. We know what we needed for the solar cell, like p-n junction, or what we needed for solar cells, like an electron movement and the whole movement, right? Apart from that, the solar cell have a limited efficiency. Why it's so? Let's see as an example from homojunction solar cell, what we see earlier slides. So we know the excessive heat will be wasted. That's a thermalization. So 47% is wasted through that. Then the transmission, the recombination possibility of electron and hole pairs. So the remaining efficiency is around 33%. So we can say that's the maximum. In a way, whatever you change or whatever you adopt as a new mechanism, still we have some limitations in solar cell efficiencies. So the research world, or in a present world, all the researchers working in solar cell wanted to bypass these limitations wherever it's possible. So wanted to get get an extra or an upgraded efficiency, we can say. Right, so that's the primary focus. So we need to have an upgraded efficiency. We need to have an solar cell for a sustainable environment in a long term. Right, so that's a primary focus. So in a commercial market now, bypassing the first generation, we have also second generation solar cells from the thin films. Name few, there are some amorphous silicon or organic or cadmium telluride or copper indium germanium selenide thin film solar cells. And there are some concentrated photovoltaics, and there are multicrystalline and monocrystalline silicon solar cell more in a commercial markets. To the basic like an idea to get how important is the silicon, I just wanted to show. I just wanted to bring in a value like it's around, I think, if I remember rightly, it's around 85% of the market is based on silicon. So if we want to, with the silicon, we have a lot of limitations. That's a second story anyway. I will show you when I compare with perovskite. So we want to pull in the market with other types of solar cells, even though there are new commercial markets which popped in, but still the 85% is a big value for a big value in a commercial field, in a commercial value, right? So these are the things you should keep in your mind before doing a research on solar cells, right? So far we were talking about homojunction solar cells, right? So we know there are some limitation in a homojunction. So there are possibility for creation of multi-junction. So that's the second stage of solar cell with a consideration of point in a mind, like getting a maximum current and voltage. So that by that way you can get a maximum power. Right, with the multi-junction, when you have different materials, or we can say composites or the layers in another terms. For example, if one layer have a 0.75 electron volt band gap and another one with a 2.5 electron volt, still there are some competitions between these layers. For example, with the lower band gap here with a high current possibilities. So there are possibility for excess energy loss to heat again. With a band gap of 2.5, there are possibility for high voltage here. By the way, anyway, the power maximum can be achieved, like either current or voltage has to be in a higher scale if we have to maintain the power max. So with these things in mind, there are constructions which going on or the upgradation which going on with the multi-junction solar cells, keeping all these band gap values, keeping all these Imax and I voltage values, and keeping all the even the disadvantages or the competitions between the layers. So when we are thinking about multi-junction, you need to bring in more and more inputs in terms of physics to make a perfect multi-junction solar cells. So to name to name as an example here, the multi-junction material here is a gallium indium phosphide with 1.9 electron volt, gallium indium arsenide with 1.4 electron volt, and germanium with 0.7 electron volt, which covers almost all the spectrum range, and keeping other things in factor consideration, and the efficiency recorded value in 2005 was 39. So that since then there were researchers going on with the multi-junctions to improve the efficiencies, to bring on with the different mixtures or different composite layers to make still furthermore increased in efficiencies. There were also a possibility for multi-junction solar cell to bypass the limitations from the homojunctions in many terms. Even the crystal lattice alignment between the layers, and there are new techniques for the deposition of those layers, which kept on restructuring the efficiency factor of multi-junction solar cells, or of solar cells in general. We can see. So this is just an example of like first generation and second generation and third generation efficiency mapping. right? So even there are some well-known graph for solar cell efficiency with different materials, crystalline silicon or single junction gallium arsenide or the multi-junctional cells, or the thin films for it have some maximum efficiency recorded up to 24%, or there are new advanced multi-junction materials, as I told you in previous slides, which have shown to improve the efficiencies compared to other types of solar cells. And now there are emerging solar cells which included perovskite materials. There is like a boom in efficiency, we can say, within a few years of research. So now the interest also pointed out here, which shown which increased efficiency within the limited number of years of research and increased performance in many terms. So the perovskite brings into like a light, we can say, or shed of light. So even our research work also concentrated on perovskite solar cells. The perovskite is a type of solar cells which include the perovskite structure compound, most commonly an hybrid organic or inorganic lead or tin halide based material as a light harvesting active layer. So the perovskite materials such as methyl ammonium lead halides and all inorganic cesium lead halide are cheap to produce and simple to manufacture. So for example, this is a perovskite structure with an A, which is like an organic cation, and B is an inorganic cation. X3 is an halide or halogens. So halide anions are also fixed within this perovskite compound, right? So these are the basic structure. As I told you, when compared to multi-junction solar cell or compared to other types of solar cells, perovskite solar cell or perovskite absorber layer, the light absorbing layer within the perovskite solar cell, it's very easy to manufacture, cost effective. That's the most important factor. Perovskite, you can make a layer by layer growth or layer by layer deposition using a spin coating machines, even within the very less equipped laboratory conditions, we can say. So that's a more important criteria here. It's very easy to deposit, very easy to construct, or very easy to fabricate the solar cells. So that's the one thing. Apart from that, when compared to other types of solar cells, even the open circuit voltage, the graph shows upgraded for performance of perovskites, even when we are comparing with other types of solar cells which have an greater efficiencies. So there are more other advantages when we are shifting from the traditional silicon to perovskite solar cells, because a silicon solar cells, which is expensive to purify, but mass production reduce cost significantly in another terms. But in perovskite solar cells, mainly it's a solution processed, so lowering the manufacturing cost as a whole, and it's very easy to fabricate in laboratory conditions. When you are comparing the durability with the silicon, of course, there is a disadvantages. We need to think, or we need to think in a research perspective to increase the durability. That's a major disadvantages, we can say, because in silicon solar cells you get up to 25 years in outdoor condition, but in perovskites the durability as shown recorded was like up to 1 year. But the efficiency factor, that's somewhere comparatively better and also competitive when compared to the other traditional solar cells available in market. So efficiency wise it's okay, and the cost effectiveness simple to manufacture, but the major criteria we need to think is the durability. All right. Yes. So this is another comparison graph up to the recent years, comparing the efficiency values, for example, with the crystalline silicon and cadmium telluride or CAGS and amorphous silicon. If you see the perovskite, it's just popped in 2010, but shown an increased efficiencies, recorded efficiency when compared to other solar cell devices. So that makes like an importance towards solar cell, perovskite solar cell, right? So now now I wanted to talk about how the solar cell based on perovskite material can be constructed. We need to have an active layer, that's a perovskite, like an absorber layer. Then we need to have an electron transport layer and hole transport layer in opposite directions. So of course, basically we need a transport conductive oxide. Above that, we are trying to deposit other layers to start with an electron transport layer, then the perovskite, then hole transport layer, and then finally an electrode. So this is a conventional perovskite solar cell device, and an inverted, which comes in an inverted form with the hole and electron transport layers are shuffled or swapped. So with other points to be considered here, we need to know either the compact titanium dioxide or also there are some mesoporous layers that can be added, or there are nanowires can be added together with the compact titanium dioxide. In particular, this mesoporous titanium dioxide is commonly used as a used here as a scaffold to support infiltration of perovskite absorber and selectively extract electrons from it. So this is needed just to enhance the conversion efficiency of the perovskite solar cells. In addition, this mesoporous titanium dioxide exhibits an appropriate band alignment with the perovskite layer and a long electron lifetime, which effectively reduces the hysteresis behavior of perovskite solar cells. So these mesoporous layers is usually are generally integrated with the electron transport layer. Even our research work also concentrated on the electron transport layer separately. I will show you the slides of results in a later stage, where we are concentrated on using zinc oxide together with titanium dioxide layer to calculate the efficiency factor with a change in efficiency factor with the introduction of bilayer here. So the traditionally compact titanium dioxide and mesoporous titanium dioxide are existing as of now, and still there are some researches going on, particularly concentrating on ETL and particularly concentrating on HTL, like whole transport layer separately. We have also did a few works concentrating on these different layers, like from the perovskite layer we have started. Then we have also concentrated on electron transport layer. We have concentrated on whole transport layer in a later stage. We have published a successful publication in all these researches. Anyway, I will show you in later stages. So apart from that, there are some degradation factor need to be considered. Those can be altered or handled by considering the few factors like a perovskite lattice and surface, the depositions. When you're depositing, you need to consider which base layer you're depositing this perovskite. So based on that, you need to consider the all the crystal orientations things. So that's a crystal structure. You need to bring it. You need to think about it like an interface structures. Then you need to think about perovskite compositions. There are some variation of perovskite compositions. I will show you in a later slides. And there are possibility for making a additional layer together with the whole transport layer, for example, which is shown here. With the whole transport layer, which is with traditional whole transport layer, there are possibility for air to react and water to react. So the few research works also concentrated on forming a carbon, like a nanocarbon layer between the HTL and the anode, and the electrode. In that way, the reaction of air and water is stopped. So these are the things you can consider, like making a bilayer, which can be adopted without changing any efficiency criteria. So still, we need to concentrate much more on this degradation factor anyway. One such things, which is like an low toxicity lead-free materials, can also be preferred when just maintaining the perovskite structure, but removing the lead alone, so the toxicity can be reduced, right? So there are possibility for many combinations, including tin-based, germanium-based, antimony-based, or bismuth-based perovskite formation. So these are the things can be considered for perovskite layer solar cell devices constructions. Then here, so this is like a graph which particularly shows efficiency value changes with respect to the perovskite absorber layer alone. So, for example, there can be a combination of halides, which like iron and chloride, or with a change in lead. Instead of lead, you can use another material, as I showed you in previous slides. So with this one, there are possibility for the efficiency value changes, which shown here with the different combinations anyway. And apart from that, there are many different combinations you can consider, starting from electron transport layer or the perovskite layer itself, as shown in the left side. You can make up different combinations, either replacing the lead or replacing the halides. But the priority is to maintain the perovskite crystal structure. That's more important. And there are possibility for changing the HTL, like a whole transport layer, either with small molecules or the polymer or the inorganic HTL. Then finally the electrodes, even copper, gold, or silver. So these things can be like altered, or there are quite variant you can choose. That's what I'm saying. But when you're considering the ETL, you need to check all the values of energy things. That's why this slide shows the different combination of electron transport layer or perovskite or HTL, everything with the energy values. For example, this should be like from the perovskite layer, the whole has to be transported to the transport layer. So the energy value should be HOMO value should be maintained here, and likewise there are electrons should be transported here. So the LUMO value should be in combination or in relative to the perovskite and here. So that's more important criteria before you're choosing ETL or HTL or the perovskite itself. So you can combine in a wide variety of choices, but main criteria is to maintain the energy values of LUMO for electron and HOMO for holes. So that has to be transported without hindrance. That's the primary goal. So with this one, I just wanted to go to our experience. We started, of course, the Selvakumar did a great work in this one. All the papers are from his ideas and his contributions. So he started with the performance of perovskite layers. He have used powder press technique initially with this combination. So he has prepared methyl ammonium iodide first before forming a perovskite. So he did few alternatives within the available research works, already published works. So he did some changes within those things, and he made an methyl ammonium iodide with the methyl ammonium iodide. He used a different composition of lead iodide, then mixed with solid state reaction techniques and heat treatment, grinding, and he did he prepared different perovskite absorber layers. So we did few SEM and TEM images to understand the morphology of different composition of methyl ammonium iodide and lead iodide combinations. And we find also we did find quite varied morphologies. Of course, it's clearly reported in Material Research Bulletin published in 2018. We did all the studies like XRD and all those things, UV studies. All right, I just wanted to bring in the device performance value. He also have fabricated a device with these different combinations using the different combined materials he prepared with a 0.5 to 3 ratios or 1.1 to 3 ratio of lead iodide and methyl ammonium iodide, or 1.5 to 3 and 2 to 3 ratios. We also did few like IV calculations and found photo conversion efficiency in particular to certain combinations. Of course, it's explained anyway in the paper. Apart from that, we did apart from just fabricating the device, in all our work, we also calculated the device degradation performance. Like we did calculation for every day and check how these fabricated devices is getting degraded with their efficiencies. That's more important part of our research, we can say. In all the devices, we did I think more than a 50 number of devices, and we did calculation of degradation performance for all the materials, all the devices. That's a major part what he did in his PhD. Okay, so this is a research work concentrating on absorber layer. Then we also did a few research work on whole transporting layer. To start with, initially, he have used nickel sulfide and carbon composite whole transporting material, keeping the perovskite layer as such as from our previous experiences. So anyway, these things are clearly explained in materials letter in 2018, how we prepared, and all the synthesis techniques are explained. The carbon composites, like it's prepared in 3 variants, like a 90% of nickel and 10% of commercial carbon based, and 80% 20 and 70 30. So that's we prepared 3 different HTL layers with these combinations. Of course, just a minute, yeah. So we did also like calculated all the structural values or properties or morphological things. We did reported clearly about all these things. Like for example, this is just a nickel sulfur, and when combined with carbon 10% and combined with carbon 20% and carbon 30%, how those morphology changes, what are those surface area value changes with respect to these things, and how it affects our performance finally. For example, so with the introduction of carbon paste as like a additional layer within the HTL, we find an increased value of efficiencies, but also with increasing carbon to 20%, we still see an increased value. But when we keep on increasing the carbon to 30% and more, there's a degradation of efficiency values. There's a possibility for the holes or the pores are getting blocked, which stop the carrier transportation further. So the efficiency is degraded. That's one possibility what we thought. There may be more agglomerations later on, which also stopped efficiencies. As I told you, we also calculated the degradation of efficiencies related to number of days. We also did such calculation for these devices. Then later on, after did HTL work, we also did few other works on carbon-based whole transporter itself. So far, we were used nickel and carbon paste. So we thought of use the carbon layer itself as a whole transport layer, which acts as a both as a layer and also a resistive layer for the degradation, right? Which I showed you in previous slides. There are possibility for adding a carbon layer within HTL to stop the degradation or to stop the moisture reactions, right? So just shifting from those things, we thought of add a carbon layer itself, like a bifunctionary layer. But we have used naturally derived carbon material. We did a carbonization or graphitization later on after the carbon is derived from these leaflets, which we reported in scientific report Nature publication in 2020. All those steps were clearly explained. All the leaves first mixed with ethanol and distilled water, then dried, then acid treatment for carbonization. And then final step in the carbonization is an annealing. Then later on, we did graphitization process with a different annealing temperature of 450, 850, and 1000 degrees Celsius. We did also calculated all those gravitation values from XRD and Raman. Then the third step is like a brush painting approach. There are quite number of advantages when we compare to other deposition process. Speed fabrication, then a low material loss, processability on various substrate, even on non-flat surface such as fence and roof. Moreover, because direct brush painting of limited solution on thermally controlled substrate causes fast solidification of film, critical control of film thickness, and smoother surface morphology is also possible. So that's why the brush painting technique was used. If you see here, it's with different annealed, grown like graphitized carbon in different annealed temperature, like in 450, 850, 1000 degree. So these are the steps we followed for the brush painting approach. Of course, these graphitized carbon in different annealing temperature shown a performance, like an shown a structural variations when we can see from the XRD and Raman values. The increased in annealing temperature also increased the gravitation value. You can see from IG value of 0.75 when compared to the carbon annealed at 450 degree, which have IG value of 0.96, which means there is an increase in gravitation. Also, XRD also matches here, which have a narrow band at 24 degree to theta value, which correspond to 002 of carbon, which makes which shows an improved gravitation of 1000 degree annealed carbon. Right. So we also did BET analysis and check how the pores are changing, which explain here with different annealed temperature. Of course, the major part here I wanted to show, this is the one which I wanted to show you because this is our the primary perovskite layer with these combinations. Then we did a carbon layer coating as a graphitized carbon, which is well imaged in TEM. So this is one example of carbon with annealed 1000 degree temperatures. So this is the device we fabricated. As I told you, we did use brush painting carbon layer technique, brush painted technique for carbon initiation layer deposition. Right. So this is our devices with electrode and HTL and perovskite, then porous and dense TiO2, and finally glass. So this is our devices, and we did also quite variant device performance calculations with newly derived carbon from the natural leaf and different annealed temperature of 450, 850, and 1000. And we did also compared with our previous commercial carbon paste and nickel sulfide layers, and also commercial carbon paste without any interfacial layer, just a HTL, and with interfacial layer of 150 nanometers. So we did a quite number of studies on different combinations of HTL, keeping the perovskite as a common layer for all the HTLs. So we just wanted to show the differences related to HTL alone, with interface, without interface, and with carbon or without carbon. That's our primary goal here. There are quite different values we achieved. We also did some theoretical understanding of such value changes with related to the carbon morphology or the carbon pore size also. So these are the things it's clearly explained here anyway. So this is our aim, to get a carbon, finally to get a carbon as a whole transport and also as a counter electrode. So like a double function layers, but that carbon also should be like a grown or naturally derived carbon. So the environmental consideration is also into the factor when we did this research. So that's our final goal anyway. Later on, we did also studied on electron transport layer, keeping other layers in common, like perovskite layer and HTL in common. And we just did some changes with the electron transport layers. We have used zinc oxide and titanium dioxide together, like bilayer functionalities. So this is also a naturally derived zinc oxide process, green synthesis of zinc oxide nanoflakes from the Albizio amero leaf. So these are the things explained in a new Journal of Chemistry, which was published last year. So with the zinc oxide preparation from the green synthesis technique, we used as an electron layer anyway later on, for example here, together with the titanium dioxide. So this is how we did a device fabrication by using a spin coating technique. We did like FTO, then the compact TiO2, then the porous TiO2, then the perovskite, right? So between these one, we have introduced zinc oxide. We'll show you the importance of such the introduction of zinc oxide in a nanoflakes. So we did some morphological studies on those one. This one only with the titanium dioxide, and this one with zinc oxide nanoflakes. So when we have titanium dioxide and perovskite, we have a micro-sized pinhole here, but with an zinc oxide nanoflakes, the micro-sized as decreased to the nano-sized pinhole around few nanometers. So by this way, for example, if you see here with the compact titanium dioxide, there are possibility for the recombination of electron and hole at some point, so which makes a degraded performance. But when we introduce the zinc oxide nanoflakes between the to the top of compact titanium dioxide, then the recombination is inhibited, we can say. So those things can also be matched with the device performance later on, which I will show you in next slide. Anyway, right. So this is how we have used glass or FTO, then compact titanium dioxide, zinc oxide, then the perovskite layer with the iodine and chloride, then the spiros and HTL here, then an electrode. So this is the energy values of our materials which we used in device constructions. So we did a performance study when compared all the three combinations, only with titanium dioxide and only with zinc oxide, and with zinc oxide and titanium dioxide. So we see a change in values. In other terms, we see an increased in performance when we have zinc oxide and titanium dioxide together. This can be matched with the morphological changes and also with the recombination inhibition possibilities, right? So these are the quite variant we have used in our research. We did concentrated on all the varieties, like as I showed you in previous, so a few slides back. You have a variety of choices in choosing ETL, HTL, and perovskite, right? So that's our primary goal. Finally, we varied all the possible combinations in ETL, on all the possible combination within HTL, and all the possible combination within the perovskite. So we did all the device performance calculation, also the degradation calculations. So finally, we also wanted to introduce a naturally derived process of carbon and zinc oxide. We also did some successful work on that and published. So that's our final work. And finally, Selva also completed PhD with this one. That's also a successful story on this one. Anyway, within to the final slide, I just wanted to acknowledge TechUp India and Woodforsk Norway funding program for the research works, what we did in CIT and in Bergen, Norway. So thanking you for your kind attention, and also if there are time enough to make a questions, yes, still welcome.
Thank you, sir. The session is now open for discussion. Participants can post their questions and queries in the chat box. Participants, kindly post their questions and queries in the chat box.
But if you still have any questions, still you're welcome to mail me in this address. I'm happy to discuss further.
Participants, if there are any questions, do post it in the chat box. Sir, there's a question from Ara Chauhan.
Yeah. Mostly those are the reported values, I guess, or even there are many ways to calculate the energy values from the UV and all the studies. Anyway, there are more reported values in. Is Muggle joined?
No, sir, not yet. Thank you for your valuable input, sir. We got a greater level of awareness on perovskite solar cells.
Yeah, thank you then. Thank you, madam.
Now we have an announcement regarding the oral and poster presentations. The oral and poster presentations will be happening in 2 parallel sessions by 5 p.m. after the invited talk 7. The oral presentation numbers 33, 34, 46, 47, 48, 51 will be presenting in the same link. The oral presentation numbers 9, 41, 45, 49, 50
டாக்டர் ஸ்மகுல்
are requested to join the
இல்ல அவர்
parallel
வந்து
oral
நீங்க போட்டிருக்கீங்களா
meet link, which is
இல்ல வந்துட்டார் போல
posted in the
இருக்கு.
chat box by 5 p.m. The poster presenters The poster presenters 31 to 43, 46 are requested to join the parallel poster presentation link by 5 p.m. which is posted separately in the chat box. The oral and poster presentation will be happening in 2 parallel sessions by 5 p.m. The oral presentation numbers 33, 34, 46, 47, 48 and 51 will be presenting in the same link. The oral presentation numbers 9, 41, 45, 49, 50 are requested to join the parallel oral presentation Google Meet link, which is posted in the chat box by 5 p.m. The poster presenters 31 to 43 and 46 are requested to join in the parallel poster presentation link by 5 p.m., which is posted separately in the chat box.
Let's wait for our next speaker to join.
இரு பாக்குறேன் கான்டாக்ட் பண்ண முடியுமான்னு பாக்குறேன்
Dear participants, kindly wait. The speaker will join shortly.
Yes, hello, do you hear me?
Yes, sir, we could hear you.
Good. And do you see my screen?
Yes, sir, it's visible.
Good. So then,
MC, kindly introduce the speaker.
okay, yes.
Yes.
So
Good
then,
evening, everyone. We are here with Invited Talk 7. May I now request Dr. G. Praveena, Assistant Professor, Department of Physics, PSGR Krishnamal College for Women, to introduce the speaker for this session, Dr. Smagal Karaznau, to our esteemed audience.
Thank you. Thank you. I'm very much honored to welcome Dr. Smagul Karaznau, Senior Researcher, Department for Solar Energy, Institute for Energy Technology, Norway, for accepting our invitation. Dr. Smagul has completed his PhD in the year 1993 at Institute of Physics and Technology, Tashkent, Uzbekistan. Former to being the senior researcher, he worked at the National Research Nuclear University, Moscow. He has supervised 5 postdocs and 7 PhDs at the current institute. He has been a guest editor for some of the special issues in the journals from elsewhere. Presently, he is in the scientific advisory board of 5G solar project at Tallinn University of Technology, Estonia. His research includes materials development for smart window applications, emerging solar cell concepts, advanced materials for solar cell and smart window applications, and so on. He has published more than 100 journal articles. He has 2 patents and has given invited talks at various international events. We are really fortunate to have such an eminent person among us. I once again welcome Dr. Smagul Karaznau to deliver his talk on emerging class of materials called mixed anion materials, research and applications. Over to you, sir.
So welcome everybody to the talk. And it's great honor to me to deliver this talk to your audience. And I'm very thankful to organizers for inviting me to this conference about breakthroughs and approaches in contemporary scientific research. And I have a long story of working with the Indian scientific community. I have ongoing running collaboration with many Indian institutions, universities, with Indian Institute of Technology and research institutes. And it's a great honor to me to deliver a talk in this conference also. So, as you know, materials research is a very necessary part in all, I would say, this material science-based research, in particular in solar cell technology, for example, in smart windows, in photocatalysis, in photoelectrochemical solar cells, for example, hydrogen-related research and so forth. And then many types of new materials are needed at present that on the one hand that don't exist in the nature, on the other hand about finding new materials that already exist but nobody knows about their existence, or about finding of new properties of the material for some specific applications. And in today's my talk, I would like to tell briefly about the emerging solar cell concept. And not solar cell, it's not only solar cells, but it's an emerging class of materials for many applications, I would say that this would be the more correct word. And that class of materials, it's called mixed anion materials. And I would say here about research and related applications in this field. And from all the time, you might know well about mixed cation systems, or what we call multi-cation systems. And that multi-cation system, this is one of the examples. For example, it's zinc oxide mixed with tin oxide, with indium oxide and gallium oxide. Why this type of composition was needed? It's because of indium here is one of the strategic materials in the world. And there is a very strong demand in indium, in using indium. Indium is used in many of the modern devices like flat panel displays in computers, for example, and many other semiconductor devices, whereas availability of indium, it is limited. And so then the price for indium is growing up from year to year. And for that reason, it's very important to reduce, to reduce the materials where indium is used, to replace those materials with indium-free materials, or at least to use the material, but reduce the content of indium. This is one of the requirements. For this particular reason, for example, one of the well-known solar cells like CIGS, copper, indium, gallium, sulfide or selenide, and it has some limited applications. It's because it contains ITO. ITO is used in many modern devices like in smart windows, in electrochromic materials, for example, and in solar cells, for example, in other some semiconductor devices also. So the idea is to reduce indium content, but keep properties of the material in other materials that will be replacing indium oxide, for example. And these multi-cation materials came out to the scene because of the necessity of reduction of the indium content, but keeping the property the same or improving the certain property the same. So the idea was, in the multi-cation system, in such a multi-cation system, it was increasing mobility of charge carriers, but reducing indium content. And by mixing this type of several materials together, and by keeping optical properties almost the same, that was one of the topics. And here, as you see, an ion is in all of these materials is oxygen, whereas there are 4 types of different cations. So this is what we call multi-cation system. This is mixed cation system, okay? Now, in this talk, we will move to multi-anion systems that contains more than one type of an ion. And to this group, at present, they belong a great number of materials like oxyhydrides, oxyselenides, oxysulfides, oxynitrides, for example. And there are some examples, for example, zinc oxyselenide, zinc oxysulfide, zinc oxynitride. They can be one of the examples of the class of materials. And also, you know very well, there is one multifunctional material called titanium dioxide. When hydrogen is incorporated into it, if hydrogen will replace oxide anion, then it will become hydride anion. So then number of anions will be more than one. So this is another example of multi-anion materials, and that contains 2 types of anion, oxide and hydride anions. And then advantage of this type of material, for example, is that it might possess some new materials properties that is not available neither in pure anion nor in pure hydride. And it will be somewhere in between, or certain properties can be improved or worsened. And so this is what we call materials engineering. And this mixed anion systems has been formulated as a group of materials. And because of this new topic about materials engineering. So here is one of the examples of and anions, for example. And here one of the anions has been replaced with another one. And then by replacing the anion, one can tune electronic structure of the material. As you know well, conduction band minimum and valence band maximum, they are strongly influenced by what type of cations and anions are there. And the anion subsystem is controlling valence band maximum. And valence band maximum, this is very important for electronic charge transport, for Hall related transport, for example. And that can influence on charge transport and on the tuning of the band gap and on electronic transitions as well. So that's what is happening here. For example, if there would be no nitrogen in metal oxide, for example, this would be one band gap. And after getting oxynitride, the band gap can be reduced. So then also here are many other examples. For example, when it's not just one anion that is replaced by additional anion, but that can be, and also this can be in different site around cation as well. So in case of hydrides, what surprises one can expect in case of hydrides is that we know hydrogen very well. In many materials, it's behaving like proton with a plus charge state. But then one can expect very small ionic radius. However, when it's an ion with minus charge state, then its ionic radius is huge. It's close to that of oxide anion, oxygen to minus. And when it's a huge size, it will suddenly become difficult to diffuse in the material. But on the other hand, it will provide additional properties. It's like spherical. And then it can be tuned as well and form very good chemical bonds. So, and then making these oxide anions is expected to give additional functionality to the material. At present, as I said, there are many examples of the mixed anion materials. So among them, from oxides, people got so many different varieties of oxides. One can say also oxyfluorides and oxynitrides. Oxides among them is of course very well studied, many types of oxides and their combinations. Oxyfluoride is another example of the mixed anion material with two types of anions, fluoride anion and oxide anion. Oxynitride, I already mentioned it. In this chain, if we analyze, then we can see that oxyhydrides are very, very little studied. There is not much work on that. And our present work in our lab, it's related to study of oxyhydrides mainly and their applications. So we can see in my talk now what type of applications can one expect from oxyhydrides. Then also, of course, I can say about oxychalcogenides. For example, zinc oxysulfide, zinc oxyselenide, for example, they can be examples of it. That contains two types of anions, oxide and sulfide anion and selenide anion. Then oxypnictide, it's compared to oxyhydrides, it's more or less well studied. And also, you might have read some famous article by Janotti and Chris van der Walle about hydrogen multi-center bonds in zinc oxide, for example, when hydrogen replaces oxide anion, and then it will become a shallow donor. So this is the article is published in 2007 in Nature Materials. And so this is one of the examples of oxyhydrides, zinc oxyhydride, that consists of two types of anions, oxide anion on the one hand and hydride anion on the other hand, because when hydrogen is substituting oxide anion, hydride is substituting, then it will become hydride anion. When hydrogen is located at the interstitial site, then it will occupy bond center and form a OH complex, but that's different. And in that complex, hydrogen behaves like proton, like proton. But in this case, it will behave like a hydrogen ion. So we should distinguish these two cases. And when it's as hydrogen ion substituting oxygen ion, then it will show shallow donor properties. The point is each oxygen ion will get in total 2 electrons from the nearby cations of the zinc cations. And suppose suppose hydrogen is replacing that oxygen ion, then what would happen is that these nearby zinc atoms would donate 2 electrons as usual. However, hydrogen can host only 1 electron. So 1 electron will be just spent for forming chemical bond with nearby cations. The excess electron that cannot be hosted by hydrogen hydride, that will be donated to conduction band minimum, and then the hydrogen ion behaves like hydride. And this is a unique property of zinc oxide. And for example, in magnesium oxide, the situation is totally different. So we can see in case of zinc oxide here, that hydrogen behaves like hydrogen ion when it's substituting oxygen as well. It's of course slightly like less stable than proton, but still it exists. In case of magnesium or magnesium oxide, for example, magnesium. So what would happen is that this is formation energy for proton, and this is for hydride like anion. And hydride anion, it is compared to interstitial hydrogen. So it's hydrogen interstitial. It at the low Fermi levels, it behaves like proton, but when Fermi level exceeds, if it's more than 3 electron volt, it's in the upper part of the band gap, then it will behave like hydrogen ion. Whereas this hydrogen ion substituting oxide one, it always behaves like a shallow donor. So it's donating the free electron to the conduction band. Then also another example from the solar cell world, and you might had this zinc CZTS solar cells or CZT selenium, and this is copper zinc tin sulfide solar cell and or selenide. As you know, long time efficiency of that CZTS cell solar cell, it was too small. It was around 6%. And there was no improvement. But then some improvement happened when sulfur was partially replaced with selenium. So this when sulfur and the selenium are coexisting, this is already 2 types of anions, and then it can be said as one of the examples of the mixed anion material. Of course, here this is like a very complex material that consists of 3 different types of cations, and then it would consist 2 different types of anions as well, sulfide and the selenide anions. So that's what we can say about mixed anion materials. So in today's talk, the main applications that I'm considering, this is smart window applications. So this is what you see in the pictures, and energy saving is as important topic as energy generation. On the energy generation, I mean just conversion of energy, conversion of solar energy, for example. That can be done by photovoltaic devices. However, as you know, the energy coming from the sun, it's so small. It's just 100 milliwatt per centimeter square, and it's well distributed. And so that one should collect them and then utilize them. And but electrical energy is one of the convenient forms of energy. And that can be converted later on to many different types of forms of energy. And so then this tiny amount of energy, then we can convert it to electrical energy by photovoltaic devices. So once we are interested in collection of the so tiny amount of energy, we should save it as well. How can we save it? As you know, nowadays there exists a window in outermost walls of the buildings. It was in very oldest time. There was no window. It was just when people learned to make homes. Initially, there was no window. It was just walls. However, then later on, living standards of people were improving from year to year. Then they learned to make hole on the wall so that the light can come into the room, for example. And however, if they make hole on the wall, then rain, snow, and heat will, come in or get out. Then in such case, of course, we should close it with something else. Then people learn it to close it with some material, for example, with trees, for example, or with glass. And then that living standards of people were further improving. And then windows came to the scene. The first windows came to scene in the 13th century itself. However, they were on the heat transfer properties of the windows were not controlled at all. And since then, living standards of people have further been improved. And then by this way, double glazing windows came out, and then also triple glaze windows are coming out. They are already in the market, in fact. And why we need double or triple glazes? This is namely to control optical properties of the, not only optical properties, but also heat transfer properties, somehow to minimize heat transport. And also now energy saving coatings have been developed, and that will block infrared part of the sunlight, and whereas visible light can come into the building or get out. There are some nowadays some static coatings that will reflect heat waves. And these are such examples of the window. And however, now there are different types of such coatings. One of them is thermochromic windows that will change their color depending on temperature of the environment. So when temperature goes above 30 degrees C, then not color of the window, but light reflecting property will be changed. It will be increased so that then heat waves will be blocked and they will be stopped, reflected back. Whereas visible light can come in. And then there are electrochromic windows, and in the electrochromic windows, person can control. It's let me finish first about thermochromic coatings. Then, but the thermochromic windows, it has problem at present. Although it's commercialized, it is available in the market, but it has problems. One problem is that the very popular material is vanadium oxide, and vanadium is toxic. And the second problem is that vanadium oxide, although it's popular and it is temperature when reflectivity properties will be changed, it's too high. It was 68 degrees C at ambient conditions, but now it has been reduced to about 30 degrees C. But on the other hand, its band gap is too narrow. Its band gap is about 1.5 eV. And by doping-induced materials engineering, there is ongoing activity about enhancing its band gap. So some impurities have been found to advance its band gap. So this is and also energy saving efficiency from vanadium oxide is found to be about 16.2%, which is too small, but still it is in the market, which is good. Maybe later on, Material scientists will find a better candidate, but we don't know yet. So this is a task in front of material scientists to find such a material which switches light reflecting properties at say 25 or 30 degrees C with open band gap. As nowadays, as we see, most of the buildings nowadays that they have window glasses on the outermost walls. Living standards of people are still improving, and nowadays they want, to stay inside the building, but to see what is ongoing outside. So then for that we need windows. And can you imagine if there is a very tall building with a big building with outermost walls are made of glass, then one should certainly control its heat transferring properties and its optical properties as well to make comfortable to people inside, and also at the same time to control heat transport in the sense that in the winter days, for example, the heat inside the building shouldn't get out. It should be blocked by that coating. In the very hot days, for example, the heat waves shouldn't come inside the building. So these are the main requirements from the smart coatings. So then I mentioned it briefly now about thermochromic coatings, but there are, and one more thing to be mentioned about thermochromic coating is that it cannot be controlled by human at all. So thermochromic property of the material will be exhibited whether a person wants it or doesn't want it. So, and there is another type of coating, which is called the photochromic. And photochromic coatings, they will change optical properties of the material depending on which type of photon is falling on it. And so most photochromic films, they change their optical properties because of very harsh ultraviolet part of sunlight. So when the sunlight is on, then material changes color, say from very transparent like window to bluish, maybe to yellowish, to greenish color. And so at present, there are many types of such materials made of polymers, made of hybrid coatings, and made of inorganic materials. So which of them is good, which of them is bad? It's hard to say, unfortunately. There is no candidate, very good candidate that would be commercialized by everybody. There are, of course, many photochromic materials at present. One of the class is its oxide-based photochromic inorganic photochromic films. One of the deficiencies of them is that when color of that material is changed, then it will block visible light, which is not needed, and it shouldn't block visible light. Then there are different types of polymers and hybrid films. However, the deficiency of this class of materials is that when it's exposed to the sun, after some time, the bubbles will be formed. Then these films start to peel off of the substrate from the glass. And to prevent it, glass producing companies commonly anneal the glass and its coating at about 600 degrees C, whereas polymers or hybrid films, they cannot withstand annealing at about 600 degrees C. Inorganic materials would be preferable to use. They can withstand high temperature annealing at the 600 degrees C. But unfortunately, when the color of these materials are changed, that will block visible light. Then, okay, let's search for alternative materials. So that's, we found one of the oxyhydrides, mixidonian material. That doesn't block visible light. Color of that material is changed, but it doesn't block visible light, which is very important. I will show it in the when I start to mention about our results that we have obtained. So then there are electrochromic windows as well. In the case of electrochromic windows, human can control. For example, when it's very hot outside, human can come to the window, press the button, and its color is changed so that it will block UV part, it will reflect the infrared part. And when people doesn't need, they can switch it back to make it just fully transparent as its common window. So this is called, it's a dynamic window, and that can be controlled by human. But this let me please mention, I have mentioned you problems related to photochromic films, and let me now mention advantage and deficiencies of the electrochromic windows. So advantage, as you have seen now, is human can control optical properties. And the disadvantage of it is that human should present all the time. Of course, we can avoid presence of a human, but then there should be electronic system that will recognize when color of that window should be changed on off, and that will further complicate design of the window. And the other disadvantage of electrochromic films is that it's high tech. It's not so easy to do it. The very simplest electrochromic device consists of few layers, at least 5 layers. This is just in ideal case, but in realistic case, it's not working 5 layer. It's much more number of layers. So this is very critical. And also another disadvantage is that for switching of optical properties of electrochromic devices, one needs energy. It should be either battery or electrical network. So with all the available materials, there are some problems and there are some advantages. So just it's on the customer which one to use, which one to select for the practical utilization. So I would like to tell about yttrium oxyhydride, but the same what I will say can be extended for some other for rare earth metal oxyhydrides as well. What we want to do is, as I mentioned already, when it's shining very heavily in the outside, very strong UV is coming, it's impossible to work, for example, in such situation as I showed on the left-hand side. Then one should just block, of course, by turning down the curtain. But it's possible to put photochromic film, and so that it will be possible to see what is ongoing outside. So without blocking the sunlight coming into the building. And what we did, we started first, so it's the history of developing of this material is that it's our lab is the first who discovered this material in collaboration with colleagues from Delft University of Technology. So initially we were working with new materials for solar cells. And in that, yttrium hydride was one of the materials that we were suggesting to use it. We wanted to do transparent and conducting hydride-based film. So then we oxidized it after we'd have deposited the metal hydride. And oxyhydride is, metal hydride, especially based on yttrium hydride. And it's not so, we expected that it will not be fully oxidized, only the surface area. And then the oxide layer at the surface area was expected to block for oxygen for further penetrating. But unfortunately, that was like a wrong idea, in the sense that oxygen was penetrating until substrate. So, but what we found is that with this material is that it's photochromic. It changes its color even under the action of the light coming from optical microscope. So then we started to study this material, this particular property. We have studied its mechanism and ways of controlling of performance of that photochromic film. That has led us to now constructing the prototype devices. Now it's ongoing outdoor testing and indoor testing of these prototype windows. If everything is okay, then we will successfully move to technical readiness level 9. So let me briefly mention what stands for technical readiness level. Now in the European system, people started to use the terminology technical readiness level. This is a terminology that shows how far we are from basic research and where we are with respect to the stage related to commercialization. So then the lowest technical readiness level is 1 and the largest readiness level is 9. So we are on 6. 6, it means that we have prototype device developed in the lab. And the TRL is 7. It's when indoor testing has been successfully completed. And the TRL 8 is when outdoor testing is successfully completed. TRL 9, then one should pass testing in demonstration buildings. Then the material will be ready for commercialization. Then a certificate can be obtained for production of the material. So this is a procedure how to commercialize of, the material, photochromic material. So on the left-hand side, you see the human prototypes. Here is also our prototype windows, and but we have larger number of prototypes located on the other side of the building as well. So this is briefly what we are doing on oxyhydroxythium. Of course, here one can think that the color is yellowish, and when illumination is on, it can be dark, okay? But here, of course, some of the glass producers, they don't want yellow color. So that's what they wish. But we have different different argumentation against that. For example, in China, people can wear like a white color dress to when somebody died, to the funeral ceremony. Whereas black color in Europe, it's for funeral ceremony. In Arabic countries, it's for celebrations, you know. So it depends on what, on person, on human perception. Once I visited Japan and participated in the presentation by building constructors and related, scientists who did a presentation about like a colored photovoltaic devices, building integrated photovoltaic devices. And then they mentioned about different colors, different color modules. Then I asked which color is preferable for Japanese producers of glass. And the answer was that all color except bluish color. I said, why? So it's because light emitting diodes, they already provide this bluish color already. So then it's okay. Then when its window is blue and when the light coming from the lamps are blue, then it will irritate human eye. So then it's good if the window will possess a different color, different than bluish. So then it can be yellow, it can be red, it can be green, and so forth. So then we don't care about what color is it. And we are doing the preparing that coating by magneton sputtering. Of course, solar cell people can say this is very expensive technique. That's true. However, producers of glass, they are using magneton sputtering. And so then the technology, it's compatible with, with industry. And also, I should say the following, that the machine that we have in our lab, this is semi-industrial machine. Carrier size is very big. It's 0.6 meter by 0.6 meter. And we were doing the depositions by this machine. And depositions can be done on small area substrates and on large area substrates. Of course, there will be a problem related to uniformity. Compared to the centrum of the sample, at the edges, one can notice some small change in the thickness of the film. Of course, here I'm talking about glass substrates of size 0.5 meter by 0.5 meter. So, and after deposition, we are getting this type of film design on glass substrate. That is our oxyhydride film. And then at the top, there is a not pure oxide layer, but I would say oxygen-rich layer. And we did depositions on many different types of substrates, like carbon substrate and the flexible substrates as well. Our idea was deposition of this material on flexible substrates, so that then one would just glue on window. When it's degraded, then just remove it rather than just to integrate to window. That was one of our points. So then the presence of oxide layer, we have confirmed it experimentally by doing neutron-related research. So then here I'm presenting colors of different materials. Color for yttrium hydride and yttrium oxyhydride. Yttrium is metal, it's shiny reflective. Yttrium hydride is also reflective, but it's dark. Whereas oxyhydride is transparent, but it's photochromic. And by the way, yttrium oxide, it's not photochromic. It's wide bandgap material with bandgap exceeding 5 electron volt. So all the sunlight will go through it. And yttrium hydride, when it's a 3 hydride, it is transparent to visible light. Then bandgap of that material is 2.6 electron volt. However, by sputtering, one cannot get 3 hydride. One can get only dihydride. It's because hydrogen pressure is not strong enough in the deposition chamber. So once we deposit yttrium hydride, and after deposition is finished, one should expose the film outside the deposition chamber, and then the film will get oxidized. After it gets oxidized, it will become like this color. And if one illuminates it with UV light, color is changed. If illumination is stopped, or if, for example, just close the light path, light fall onto the film, then it will bleach again. So this is reversible. Initially, before illumination, light transmittance can be around 80%. So we were able to control the transmittance even above 80% or below 80% as well. So after illumination with UV light, transmittance reduces. I mentioned it at the beginning of the presentation that there will be no mid-gap states during photochromic effect or during illumination with sunlight. So if a mid-gap state would be formed, then one would see here some peaks, strong absorption corresponding to visible light, but there is no such strong absorption, and transmittance reduces evenly on all wavelengths almost. So then material possesses photochromic film, and here you can see the photochromic film on flexible substrate. So then what do we mean that this is oxyhydride? So as I said, by sputtering, we can get dihydride maximum, okay? In the dihydride, this is yttrium cation, and the blue color balls show hydrogen ions. And when it's oxyhydride, these hydrogen ions will be partially replaced by oxygen ions, and then that's what yttrium, and this is oxygen, red color balls, and the blue color balls are hydrogen ions. So it will be mixed anion material. Or alternative way of getting this oxyhydride is hydrogenate of oxide. However, this is very difficult task. It is relatively easier to hydrogenate metallic yttrium, rather than hydrogenation or oxygen reduction of yttrium oxide. Then how we know that this is oxyhydride? Well, we can know it by performing synchrotron measurements. And we did it, and so we found that this is oxyhydride by comparing these synchrotron peaks. And first, by neutron powder diffraction analysis, we have estimated how much hydrogen is there. And for that, we have used it instead of hydrogen deuterium. And then after we established how much hydrogen is there, we did synchrotron, and then we have found that these oxide ions are located at tetrahedral sites. So these tetrahedral sites are shared between hydride and oxide ions. That was our main result from synchrotron measurements. Then other interesting question is, okay, so then once we say about the mixed anion, more than one type of anion, we need some confirmation that the OH bond exists, and yttrium O bond, yttrium H bond, it should exist, okay? And as to OH, I didn't know yet, but but later on we established it exists also. So then by doing FTIR and then Raman measurements, we found that there exists yttrium O bond separately and yttrium H bond. So this is for sure oxyhydride. And then we found some absorption bands corresponding to OH as well. So the more correct title for this compound would be not oxyhydride, but rather hydroxyhydride, because there are not two types of anions, there are three types of anions. How did we know it? We wanted to clarify mechanism of the photochromic effect. And for that, we did Raman measurements up to 3600 waves in the Raman peaks. And our idea was that if we illuminate it within, for example, some 30 minutes, for example, then something should happen with these bonds, because the mechanism of this photochromic effect, it's in our opinion, related to photochemical reactions. In the photochemical reactions, some of the bonds is going to be tuned, either yttrium O bond or yttrium H bond or OH bond. And then what we have seen on the right-hand side, you can notice that the peaks corresponding to OH is tuned, which is good. It means this result, it shows light-induced tuning of OH bond. And also we found that yttrium O band, related bond is also tuned. We see here from the difference of the red and the black color lines. So then first conclusion from that is that this is hydroxyhydride, not pure oxyhydride, and that as a result of the photochromic reaction, photochemical reaction, yttrium O bond and OH bond is getting, changed. And the same can be said about yttrium H bond. Yes, and the films are polycrystalline. So this is just common feature for all sputter deposited thin films. The structure will be columnar. So we have observed this type of columnar structure by high resolution TEM and by SEM analysis and cross-sectional SEM as well. And also when the film will be oxidized, oxygen will penetrate, and then the film will become porous. And then the largest the grain size is around 20 nanometer. So then also we have performed the cyclic testing on by cyclic testing by performing illumination on and off many times. This is one of the requirements from glass producers. So then we have achieved that the film contrast will be more or less stable. So compositional analysis has been performed, and also optical studies systematically has been performed by different methods. And then by compositional analysis that was performed by using ion beam analysis instruments. So we have established a correlation between materials properties like optical properties and film composition as to concentration of hydrogen and oxygen and deuterium. So yes, this is briefly what I would like to say to your attention about photochromic films, about mixed anion materials and its functionality. So they can find good application in window industry as photochromic coating, but also, but it's not limited to that particular application. One of the other applications is it's photoelectrochemical solar cells, for example. As you know, this titanium, black titanium, for example, which is also mixed anion material, it's showing more advanced properties in energy storage, and also in the energy storage, and it has more advanced antibacterial and other properties. Whereas you now know about the performance of our material oxyhydride of yttrium for smart window applications. So, but it might present also interest for photoelectrochemical solar water splitting also. So, and at least our latest results on electrochemical stability is showing. But since it is oxyhydride, we think that the material is expected to be electrochemically not so well stable, but the latest measurement shows that it's stable. On the other hand, the other parallel study in collaborators group was showing that the material is unstable. So time shows, and market will determine whether this material is needed to the market or not. Then thanks for your attention. And we have 10 minutes time. You are welcome to ask any questions. Thank you.
Participants, now it's time to shoot in your queries and clarifications. You can post your queries in the chat box. Participants, kindly post your queries in the chat box.
So you are welcome to ask questions and by emails as well. Just feel free to do it anytime.
Thank you, sir. Thank you for your comprehensive session. Sure,
Thank you.
the participants have gathered explicit exposure in the field.
I didn't hear what?
Sure, the participants have gathered explicit exposure in the field.
In the
you,
field.
Sir.
Yes, yes. The field testing is ongoing. It's not yet completed. So we are studying now how the performance of the photochromic films, like speed of switching the color, speed of breaching film contrast is changed at the different weather conditions. In winter days, in summer days, on spring, on autumn, those things we should clarify. And in different other climate conditions, for example. So in case of Norway, we should finish that testing and then we should move to testing in India, for example, or in Turkey and in America, because those are expected to be, commercialized to be the market for those countries. So then in those specific locations, some testing should be performed. But what we feel now is that in winter days when it's cold outside, color switching speed is somehow slowed compared to summer days. So, and also if humidity is very high, that's influencing on the color change also and on film degradation. And that has led us to the idea to put the film in between the glazes of the window. So that's what is ongoing now.
No more questions, sir. On behalf of Departments of Chemistry and Physics, we thank you for your valuable time, sir.
Thank you. Bye-bye.
The final sequence of the day is oral presentations. The oral presentation numbers 29, 33, 34, 46, 47, 48, and 51 will be presenting now. Now I invite Dr. G. Selvi, Assistant Professor, Department of Chemistry, PSGR Krishnamal College for Women, to chair the session.
Good evening, all. Thank you for the opportunity given. Shall I call upon the first presenter, OP29, to present?
The first presenter for the evening is OP29, K.S. Kiran, to present on crystal and molecular docking and studies of bis cyclohexyl diols with focal adhesion kinase inhibitors.
Madam, if you close that, I can share the screen.
Yes, sir, you can proceed now.
Sharing the screen. Am I audible, madam?
Yes, sir, you can proceed.
Okay. Screen is visible, madam?
Yes, sir. Yes.
Slides are visible?
Yes, you can.
Yes, sir.
Okay. Can I start?
Yes.
Okay. My topic is crystal and molecular docking studies of bis cyclohexyl diols with FAK as the inhibitor. In this, main ultimate this one is we were aiming at drug design. One is by stabilizing the crystal structure as well as by docking studies to identify the target protein with the FAK as the inhibitor. Outline of a talk is introduction, material and methods, preparation of the ligand, preparation of the protein ligand interaction using autodock, binding site prediction, docking energy calculation, results and discussions and conclusions. This cyclohexyl diols is a non-planar molecule. Constantly it is flipping up as well as the flipping down exactly at the C9 position, one with 2,4-dinitrophenyl as well as 2,4-dichlorophenyl exactly at the C9 position. This bis cyclohexyl diols shows the significant characteristic feature towards anti-cancerous as well as anti-tumor activity. Crystallographic studies of these molecules have a better insight. Whatever the newly synthesized compound for the bis cyclohexyl diols, they have better insight to have the improved the biological activity. And also, second thing is stabilizing the structure. One can expect to have better insight to the drug design. Third part is the docking studies provides a more rational approach for the receptor interaction to a approach for the drug design. This is the R-tip diagram obtained for the first molecule to 3-hydroxy to a hydroxy diphenol, exactly at this E9 position dichlorophenyl. This is the expected structure we got. From the results also we got the same in order to have the better confinity for the stabilizing the structure. This is crystal data obtained for the first molecule exhibits in the monoclinic with P2 upon N with the unit cell dimensions. Unit cell dimension ABC value, and the final R value is obtained around 1.223 and also 0.702. This is the packing diagram obtained to study about the CHO interaction between the molecules. In this, hydrogen bond is not involved; it has been omitted. You can see the packing how exactly it has been interacted with the neighboring atoms. Second part is the molecular docking. It tells about the protein structure, predicts the binding sites, lead optimization, virtual screening, chemical mechanism studies, as well as the structure-based drug design. This is the flow diagram for the molecular docking. Ligand is my newly synthesized compound. Protein is the receptor, identifies FAK. Future, the drug is the ultimate aim for the receptor with the ligand. Here the protein, whatever I have chosen for the docking studies, I have chosen as a focal adhesin kinase. It is having a better functionality with respect to the spreading around themselves, moving around, cellular addition, migration, as well as stick together with their surrounding molecule. This is a docking structure obtained using the AutoDock. You can see that newly synthesis has been defined with the FAK. These are the surroundings of the amino acids. This is using the AutoDock. Same has been compared to the FlexX. Also, you can see we're calling this one as a binding force. You can fitness with the exactly with the binding site for the surrounding amino acids. This is to tell about how exactly the protein ligand interaction is there with the surroundings of the amino acid to study about various van der Waals covalent, etc. These are the residues of the amino acids. We are using the Discovery Studio software to study about the protein ligand interaction with the amino acids. This is called as a dig plot to study about the molecular surface around the surroundings of the amino acids. We are calling this one as 2D interaction representation, residues in the molecular surface. This is the results obtained. We are starting from 1 to 10. Binding energy minus 6.13. The lowest one is for minus 4.33. Inhibition constant is 32.02. Lowest is 635.61. Higher the negative value, the better affinity for a molecule. These are the residues of the amino acids. Similarly, we are able to calculate the pose rank from 1 to 10. The dog score we have calculated. Minus 10.62 is highest one. Lowest is minus 6.81. These are the residues of the amino acid you might have seen in the previous diagram. Later stage is the third part. This is only the challenging one to identify the disease. You have to isolate the protein, find the future drug as well as the preclinical trial. One is we have to go for the various process. One is the combinational chemistry, molecular modeling, in vitro as well as in vivo studies.
Excuse me, sir.
Yes, madam.
You can concise your presentation. It's
okay, madam. Fine. In the results and discussion, whatever the highly highlighted the ligand is there to confirm to better affinity to the fit of the target protein. In the present studies, one is dichloro with 5-hetero. We got around minus 6.43 with inhibition constant 19.68. Further co-crystallization of this with taken to the animal trial followed by the feasibility has been encouraged. In the conclusion, the intramolecular interaction between the ligand and the protein was investigated. Bioactive compound interacting with the compound taken as a potent inhibitor to block the FAK protein. The selected compound can be used as a validation to have the preclinical testing to use it as effective anti-cancerous drug. I would like to applaud this VGST Vision Group of Science and Technology Bangalore for funding this project, as well as the Guru Rao and also our director Jain University for encouraging this project. Thank you.
Thank you, sir. Thank you for it's a nice presentation. Yes. I'm having one question.
Yes, madam.
How many hydrogen interactions have you found in the protein, that is with your molecule and the protein? The
Madam,
number of
that is
hydrogen interactions.
number of hydrogen interaction around, we got around more than 200 plus, madam.
With your compound?
Yes. With respect to the molecular survey, exactly we'll get that is called as a Lick plot. There we see the exactly how exactly the hydrogen has been involved in the molecular surface.
Audience, is there any query from audience side?
Madam? Hello? Can't hear properly. Hello?
Participants, if you have any questions, you can ask. Thank you, sir. If there is no question from participants, thank you, sir. Thank you.
Okay. Thank you for giving the opportunity. Thanks, organizers, for giving an opportunity. Thank you.
Moving on to next presentation. The second presenter for the evening is OP51, M. Nandini, to present on design and development of machine learning model for polymer classification. Kindly share your screen and unmute your mic. The second presenter is OP51, M. Nandini, to present on design and development of machine learning model for polymer classification.
Ms. Nandini, are you ready to present? Ms. Nandini?
Let's move on to the next presenter. The next presenter for the evening is OP48, Gayatri K, to present on decolorization of synthetic dyes and dyeing industry effluents, a comparative study.
Thank you, ma'am. Am I audible?
Yes, ma'am, you're audible.
Yes. So I thank the organizers for giving me the opportunity. Ma'am, next slide, please. Okay, so in this conference, I'm going to present my research work, which is nothing but decolorization of organic dyes and also industrial effluents using two adsorbents, namely called as glucose grafted polyacrylamide graphite and glucosamine grafted polyacrylamide graphite as adsorbent. Okay, so we have selected 4 synthetic dyes from different classes, namely methylene blue, direct blue 6, acid violet 17, reactive red 2. So the structure of the dyes which we have chosen is shown in here. Ma'am, next slide, please. Okay, so we have synthesized 2 polymers using a free radical polymerization technique using ammonium persulfate as an initiator. Okay, so in short, a mixture of glucosamine and a graphite is taken in a round bottom flask, and the solution is heated around 70 degrees Celsius. To this solution, ammonium persulfate initiator is added dropwise, and the solution mixture is pre-treated with the initiator for around 30 minutes. After that, polymer, a polyacrylamide is added dropwise, and this reaction is continued another 3 hours. After that, the solution mixture is dispersed in an acetone ethanol mixture. After that, it is dried around 70 degrees Celsius. Then it is pulverized and sieved through 125 micron size siever. Okay, so this is the simple structure of our synthesized polymer. So glucose crafted on glucose crafted on polyacrylamide graphite composite. So the simple schematic representation is shown here. Okay, so we have used, next slide please. We have used these 2 copolymers as adsorbents for the removal of synthetic dyes from aqueous solution, as well as for the decolorization of industrial effluents. And this we have collected industrial effluents from the nearby Chipcart industry. From the knitted fabric processing unit, we have collected the effluent. Okay, So batch adsorption studies for organic dyes, we have varied the many parameters like adsorbent dose, initial concentration of dye, contact time, pH, temperature, as well as we have studied adsorption thermodynamics, isotherm, kinetics, desorption studies, etc. And for the industrial effluents, we have studied the parameters like color, pH, conductivity, total dissolved solids, hardness, chemical oxygen demand, biological oxygen demand as per standard methods. Next slide, please. Okay, so this is this table shows the parameters which we have studied for industrial effluents before and after adsorption using our copolymers. Okay, next slide, please. The same effluents we have studied for another copolymer, that is glucosamine grafted polyacrylamide graphite composite, and you can see this table. Most of the effluents are highly colored and alkaline in nature. Okay, and we know that the characteristic of wastewater produced from dyeing industries contains a lot of dyes, and also this requires a lot of chemicals. So this increases the total dissolved solids of effluents. And the total dissolved solid values of all the effluents are above 6,700 ppm. And the ionic strength of effluents reduces the adsorption efficiency of polymer composites. You can see this table. We have compared the efficiency of our copolymer before adsorption, after adsorption. BA stands for before adsorption, AA stands for after adsorption. So most of the effluents are highly alkaline before adsorption, but after adsorption, the pH is slightly considerably reduced. As well as the TDS, you can see the total dissolved solids before adsorption was very high, but after adsorption, it's considerably decreased. Like chloride also, the chloride content of water, it actually doesn't affect much, but it is corrosive in nature. So the chloride content also reduced significantly after adsorption. So likewise, many parameters we have studied. Okay, ma'am, next slide, please. And we have compared the efficiency of copolymers for the removal of synthetic dyes from aqueous solution, as well as for the decolorization of industrial effluents. So you can see in this table, so the efficiency of polymer composites are very high for synthetic dyes than the industrial effluents. The reason is organic dyes, the removed from aqueous solution, are free from dissolved solids, sulfate, chloride, and other chemicals. And also, so that's the reason aqueous solution means organic dye removal from aqueous solution shows high percentage of removal than the industrial effluents, because we know industrial effluents contains lot of chemicals, so which reduces the adsorption capacity of polymer composites. And one more thing, the parameters we have optimized, the parameters which we have optimized for removal of organic dyes from aqueous solution, we have maintained the same parameters for removal of color from industrial effluents. Now, next slide. Okay. So, for in an economical point of view, we have compared the cost of preparing adsorbents. So, this cost analysis includes raw material cost, solvent cost, electricity, etc. And also, in our research purpose, we have compared this cost analysis with commercial activated carbon. Okay, ma'am, next slide, please. Okay, so this is the cost analysis for preparing our adsorbents. So this, as I said, this includes material cost, electricity consumption, etc. So you can see the amount of adsorbent required to take 10 metric cube of effluent. So so among the three copolymers prepared, glucosamine grafted polyacrylamide graphite, the requirement of that copolymer is less than the other two copolymers. But the treatment cost for preparing this better copolymer is little bit high, but the quantity required is very less. Next slide, please, ma'am. Okay, so with this, I like to conclude my presentation. So we prepared two adsorbents, glucose and glucosamine grafted polyacrylamide graphite composites by free radical polymerization. So various adsorption parameters are studied for the removal of organic dye from aqueous solution, like changing the initial dye concentration, changing adsorbent dose, changing pH of the solution, and changing contact time, etc. So from that, we have optimized the best adsorption parameter for the removal of dye. Okay, and we have also studied the isotherm and thermodynamics, etc. So from the studies and after adsorption, the material was analyzed by FTIR analysis. So FTIR analysis proved that adsorption is due to hydrogen bonding, electrostatic attraction, N-pi and pi-pi attraction between adsorbent and adsorbate. Next slide, please. Okay. So, and also from the desorption studies, that means the consecutive adsorption desorption studies reveals that same adsorbent can be reused many times. And this desorption studies also again confirms the involvement of formation of hydrogen bonding N-pi interaction, which is confirmed by FTR analysis already. And among the polymers we prepared, glucosamine grafted polyacrylate graphite shows maximum percentage of dye removal than the other two polymers. So the adsorption of dyeing industry effluents before and after analysis, after adsorption shows that our adsorbent significantly reduced most of the parameters recommended by Bureau of Indian Standard, except the total dissolved solid and TDS. So, and the cast analysis shows that the quantity of polymer composites required for removal of dyes was high for means less for glucosamine grafted polyacrylate graphite than the other two polymers, but the synthetic cast for
Ms. Gayatri.
Yes, ma'am. Ma'am, one more minute. Okay, so but for the synthesis of glucosamine graphite polymer, it's little bit costly, but comparatively, when we compare other parameters, it's quite good adsorbent. Thank you, ma'am.
Thank you, Ms. Gayatri, for nice presentation.
Thank you, ma'am.
Audience, is there any queries from your side? Okay, I'm having one question. You have said that you have proven that the N-pi and pi star interaction through.
Yes, ma'am.
That these interactions through FTIR studies.
Yes, ma'am. Ma'am, we observed that some shift in frequency, ma'am. So the shift in frequency indicated that there is an interaction between adsorbate and adsorbent. So before doing adsorption, we have taken FTIR analysis, and then after adsorption, the same material we have taken FTIR analysis. So
Excuse me.
it showed lot of.
Excuse me. My question is,
yes, ma'am.
How come you are saying that N-pi and pi star attractions has been found from IR studies?
I'm sorry, ma'am. N-pi and pi we couldn't get it from FTR. Only hydrogen bonding we observed from FTR analysis. But through the literature, we thought that we asked.
Okay. How you have identified that there is hydrogen bonding?
There is a shift in frequency due to hydrogen bonding between.
Okay. Can you mention the shift? Before how it is and after how it is?
Ma'am, around 3 centimeter inverse it will be there, and in some 3 centimeter inverse, ma'am.
Okay, ma'am. Okay, thank you.
I thank the organizers. Thank you, ma'am.
Thank you, ma'am.
Thank you,
Thank you
ma'am.
for your presentation.
The third presenter for the evening is OP33 HR Pradeep to present on the study on thin film dichromated gelatin coating methods for holography. Oral presenters are requested to limit your presentations for 3 minutes. The discussion time will be for 2 minutes. Our next presenter, OP33 HR Pradeep, kindly share your screen and unmute your mic. OP33 HR Pradeep. HR Pradeep, are you in the meeting? Moving on to the next presenter, we have OP34 T Preeti to present on influence of reaction time on catalytic properties of hydrothermally synthesis SNO2 nanoparticles. OP34 T Preeti, do share your screen and unmute your mic.
Good evening, ma'am.
Good evening. You can start your presentation, ma'am.
Okay, ma'am. Am I audible, ma'am?
Yes, you're
Yes, you
audible.
can proceed.
Okay. I'm here to present my work on influence of reaction time on catalytic properties of hydrothermally synthesized tin oxide nanoparticles. In recent years, the environmental pollution has seriously threatened the human survival.
Excuse me, Nima, you can skip your introduction part. You can move on to your
Okay, ma'am.
experimental and research.
Okay, ma'am. For the synthesis of tin oxide nanoparticles, for surfactant-free hydrothermal method was used. For that, first aqueous solution of tin chloride was prepared, and then NaOH solution was added to adjust the pH to 10 and stirred for half an hour to get a white milky solution, and then it is transferred into an Teflon-lined stainless steel autoclave, kept for hydrothermal reaction at 180 degrees Celsius for different times, time for 6 hours. After the completion of the reaction, the hydrothermal was allowed to cool down to room temperature naturally. After that, the precipitates were obtained by centrifuging and washed several times with deionized water to remove the unreacted impurities. And then the product was dried at 80 degrees Celsius for overnight. And then the powders were calcined at 600 degrees Celsius to obtain the tin oxide nanoparticles. The structural properties of the synthesized nanoparticles are studied using XRD analysis. The XRD peak indicates the formation of tetragonal rutile crystal structure, and the values are matched well with the JCPDS card number. On closely observing these peaks, the intensity of peak increases with increase in reaction time, which indicates that the crystallinity of sample increases with increase in time. The average crystalline size, dislocation density, and microstrain values were calculated to confirm its crystalline nature, and found that the crystalline size tends to be increased with increase in time. And then dislocation density and microstrain values tends to be reduced, which indicates that at higher reaction time, the particles are more crystalline, and there is no defects on the surface of the particles. This is the same image of the synthesis nanoparticles obtained at 12-hour and 18-hour reaction time. Nearly spherical shaped morphology were obtained. At higher reaction time, the size of the particle seems to be large compared to the one at lower temperatures. Optical studies in UV vis absorption spectra, we can observe that the band edge shows a redshift on increasing reaction time, which tends to reduce the band gap energy, which may be due to the variation in size of the particles. The reduction in band gap value was due to the presence of less defect inside the SNO2 lattice. And in photoluminescent spectra, two bands were observed, one sharp emission band at a UV region, which is due to the near band edge emission, that is the transition of electrons from valence band to conduction band. And the visible emission peak, a broad emission peak was due to the defect level emission, which is due to the transition of electrons from defect energy levels. And on observing this, the intensity of peak tends to be reduced on increasing the reaction time, which confirms its high crystalline nature. And the reduction in intensity of peak indicates that the recombination of electron hole pairs was less, which is favorable for photocatalytic degradation. Then for studying the catalytic properties, we have used H2O2 assisted catalytic degradation, H2O2 assisted advanced oxidation process, and crystal highlight dye was used as a model pollutant. The photocatalytic the degradation property was studied, and the peak tends to be decreased with increase in reaction time. The efficiency of degradation increases with increase in reaction time, which is also confirmed from the other studies, that is from PL. Sample synthesized at higher temperature showed maximum degradation at 10 minutes while using 20 milligram of catalyst. From this, we have studied the effect of varying the duration of hydrothermal reaction time on synthesis of SNO2 nanoparticles without using any surfactant, and the formation of defect-free surfaces in SNO2 nanoparticles synthesized under 18-hour duration was confirmed from XRD, UV, and PL analysis. Same image indicated that the nanoparticle size increases with increase in duration of the reaction and seems to be uniform at higher reaction time compared to the other one. And the complete degradation of crystal violet dye was observed for minimum catalyst dosage of 20 mg in 10 minutes under normal light conditions without the aid of any external light source such as UV or a mercury vapor lamp. Thank you, ma'am.
Thank you, Preeti. I have one question to you. You have shown you have said that as the temperature increases, the size of the nanoparticle increases, isn't it? What is
Yes,
the
ma'am.
reason for it? What might be the reason?
Ma'am, for longer reaction time, it will have more time to react, ma'am.
Okay.
Hence, it can produce a large-sized particles with less defects, ma'am.
Agglomeration occurs or what?
Ma'am, I can't understand.
No, what you are saying, the particle itself is higher or the agglomeration takes place? Whether the agglomeration takes place?
No, ma'am, particle seems to be uniform, but size increases, ma'am.
In your SEM image, the particle size was given as 5 micrometer and you have noted as nanometer in your tablet column, isn't it? How you would have calculated it?
Ma'am, I can't understand where I had noted nanoparticle.
See, in your SEM image, the scale is given as 5 micrometer. And the same
ma'am.
slide you have tabulated as the particle size is nanometer, isn't it?
Ma'am, that is calculated from XRD, ma'am.
Then how you have why is the discrepancy there in your SEM image and XRD studies?
Ma'am, in XRD, it is crystalline size only, ma'am, not a particle size, ma'am.
Okay, thank you.
Thank you, ma'am.
Thank you. Moving on to our next presenter, Ruchi OP46, Ruchi Yadav, to present on linear regression approach to identify novel genes associated with B-cell non-Hodgkin lymphoma.
Excuse me, ma'am, am I audible?
Yes, you're audible and your screen is visible.
Okay, thank you. Good evening to all. I am Shubhi Bansal from Amity University, Lucknow campus, and I'm here to give a presentation on the research topic, linear regression approach to identify novel gene associated with B-cell non-Hodgkin's lymphoma. Firstly, I would like to give you all a brief introduction about what is non-Hodgkin's lymphoma. Non-Hodgkin's lymphoma is a most common type of a lymphoma in which typically the cancerous lymphocytes are present in the lymph nodes. Non-Hodgkin's lymphoma accounts for approximately 90% of the lymphomas in the human beings. Out of various types of non-Hodgkin's lymphoma, almost 90% of them are developed in the B cell. Hence, the objective of my study was to identify the novel genes involved in the B cell non-Hodgkin's lymphoma using linear regression approach. Microarray data analysis for non-Hodgkin's lymphoma using RNA bioconductor packages, functional annotation of identified genes, variant analysis of non-Hodgkin lymphoma using RNA-seq data, and gene set enrichment of identified variant, and comparative analysis of the microarray data and the RNA-seq data. Starting with the methodology that has been adapted, this is the workflow that has been used for the microarray data analysis to identify differentially expressed set of genes. The raw set of data was retrieved using geodatabase. The raw set of data file format was CL file, and in this we have taken 12 different set of samples in which 6 different type of non-Hodgkin lymphomas were taken. This is a table showcasing the various samples that I have taken from a test. The entire microarray data analysis was done using the RNA bioconductor packages. Quality control analysis was done using FE package and FELM GUI package. Normalization was done using FE package. Statistical analysis was done using Lima package as it facilitates linear regression approach to be for the identification of the differentially expressed set of genes. After identification of the differential set of expressed genes, we have done functional annotation of those genes by Geo and the pathway database. Though we all know that a microarray is a powerful technique to study the gene expression profile at genetic level, but there are certain limitations to the microarray data analysis, such as data visualization and small amount of sample amount and the labeling with the fluorescent dye defects. So to overcome this limitation, as I didn't wanted to limit my study to have some doubts over it, so we took our study to a next step by using RNA-seq data analysis to identify variants. For the RNA-seq data analysis, we have used AI database for RNA-seq data analysis, and in this we have used parent sequencing samples, 2 set of samples, and the FASTQ file format was taken. The entire RNA-seq data analysis workflow was conducted at the Galaxy tools. FastQC and MultiQC tools were used for quality control analysis. Variant calling was done using Freebay. VCF annotate, SNP EFF, and SNP annotate, SNP gene set are various tools which were used for identifying the variants. And finally, after identification of the variants, the pathway enrichment was done using geodatabase. Coming on to the results,
Excuse me,
starting
madam.
with the
You can concise. Yes. You can concise here.
Yeah, sure. These are the results that I have received using microarray data analysis. These are the contrast matrix for volcano plots for the contrast matrix for a differentially expressed set of genes that I have got. This is the result showcasing the different types of differentially expressed genes, and the most prominent result was found in the group 4 and 5. This is for the high-grade B cell non-Hodgkin's lymphoma and the mantle cell lymphoma. Further pathway analysis was done for these set of genes, and the most significant genes were found as the KRAS and the CCDN1 gene. This is a screenshot showcasing one of the pathway that has been discussed in my the previous slide. That is the PI3 kinase pathway, highlighting the genes that were present in that I have just discussed. Coming on to the RNA-seq data analysis and annotation results. These are the various plots that I have got while analyzing my variant using RNA-seq data analysis, and these plots shows that the maximum number of variants were found in the intronic regions. And this table shows that the SNPs, that is a single nucleotide polymorphism, shows the high level of variation in both the sequences that were taken. At the right hand side, these are the various other type of variations that has been found in various parts, that is the base change or the variant quality, and all sort of plots has been generated and analyzed. Further, After complete set of evaluation of the RNA-seq data and the microarray data, complete functional and pathway enrichment that has been done. After completing all this, the comparative analysis of the microarray and the RNA-seq data shows that that the KRAS and the CCDN1 gene shows a significant presence and their role in the causing of the non-Hodgkin's lymphoma, as they are having significant variation. For identifying the position of the variation and the alignment of the variation, we have UCSC browser for visualizing. In this, I have highlighted the alignment to it, and the various set of base variations that has occurred can be seen in in this. With this, I would like to conclude that analysis was done over differentially expressed genes by applying linear regression algorithm over the raw microarray data for identifying novel genes involved in B-cell non-Hodgkin's lymphoma using R and bioconductor packages. Functional annotation and data enrichment was done over each set of top 10 differentially expressed gene enlisted using Lima package. That result shows that the CRAS and the CCND1 genes were found involved in the cancer-causing pathway. Further studies were done to identify variant gene expression and their involvement in the non-Hodgkin's lymphoma by RNA-seq data analysis using Galaxy tools. The result of RNA-seq data analysis shows that 189 variant gene sets and 10,913 genes were found. Out of these, about 15 genes were found involved in 10 cancer-causing pathway. Out of these 15 genes, KRAS, RAF were found in most of the cancer-causing pathway. These genes were then visualized using UCSC browser, where they show significant variant to the reference genome. By comparative analysis of the microarray data and the RNA-seq data, KRAS, CCND1, and the RAF gene shows significant difference in the level of the gene expression in the B-cell non-Hodgkin's lymphoma. Hence, this study suggests for the further wet lab analysis to be done on these genes, as they can have a potential role in a target-specific drug designing for the non-Hodgkin's lymphoma. With this, I come to the end of my presentation. Thank you.
Thank you for your presentation.
Thank you, ma'am.
Yes, I have a question. You have done the statistical, isn't it? Is there any theoretical evidence you have found before going to the wet lab? Directly with this statistical predictions, we cannot move on to the wet lab, isn't it? Is there any theoretical evidence you have found?
Yes, yes, ma'am. The studies are being conducted focusing to this, and the motive of bioinformatics is this only, that we analyze the data statistically on various set of algorithms that are present, and applying those algorithms, we
just look at this. Is there any theoretical explanation given for the statistical predictions?
No, ma'am. As such, not exactly to this study, but yes, there are few other set of studies that has been conducted, and they have found a different set of genes to their study.
Okay, thank you.
Thank you, ma'am.
Thank you. The fifth presenter for the evening is OP51 M. Nandini, to present on design and development of machine learning model for polymer classification. Kindly share your presentation and unmute your mic.
Good evening, teachers. Am I audible to you all?
Yes.
Yes, ma'am, you're audible. Kindly share your screen, ma'am.
Wait, ma'am, wait. Ma'am, am I audible to all, ma'am? Shall I start, ma'am?
Ma'am, you're
Yes,
audible,
ma'am,
ma'am, but we can't
yes,
see
you
your
can start.
presentation, ma'am.
Thank you, ma'am. So my topic is the design and development of machine learning model for polymer classification, ma'am. So now
Share your slides. Your slides are not visible. Just your screen is visible.
Wait, ma'am. Ma'am, I already sharing, ma'am.
Ma'am, your screen is visible, ma'am. Do go to the presentation, ma'am.
Ma'am, now it is visible to all. Ma'am, now it is visible.
Yes, ma'am, it is visible, ma'am.
Okay, ma'am. Thank you, ma'am. So the polymer is nothing but it is a substance or a material, ma'am. It contains molecules. It may be repeated subunits, ma'am. So my research work is nothing but it is the main objective of this research work is to develop a model, classification model for identifying the types of polymers, ma'am. It is a type of polynucleotide, polypeptide, and polysaccharides. It is related to biosequence, ma'am. In polymer, it has a different types. In that, I choose the biopolymer types, ma'am, and I collect the data from NCBI, ma'am, which is nothing but Streptococcus pneumonia. So the biopolymer types sequence of Streptococcus pneumonia are collected from NCBI database. So totally 150 sequences are collected for this polymer classification, ma'am, and it is stored in the FASTA file format. It is nothing but the data or DNA or sequences are collected from the NCBI database, and it is pasted in the notepad and with the extension of .FASTA file. And then feature extraction. In this work, biopolymers are considered to identify the type with various features such as polarity, polarizability, charge, etc., which is extracted from Streptococcus pneumonia. Streptococcus is nothing but it is a bacteria which cause the pneumonia, ma'am. So pneumonia sequence, the features are extracted using R tool. Also, the model also developed by using the R tool, ma'am. So it has R tool has several packages to extract the features. For example, carrot and biostrings, etc. And I also use the normalization technique, ma'am. Here minmax I used, ma'am. And then technique to develop the model, I use the classifier, two types of classifier, KNN classifier and gradient boosting, ma'am. And then gradient boosting is one of the ensemble learning method, ma'am. And then model development tool, I use the R language. So classification model is nothing but it is used to identify the three types of polymers, whether it is a nucleotide or whether it is a nucleotide or a polypeptide and polysaccharides, ma'am. So these are the three types of classes I categorize using the classifiers, ma'am. And then conclusion, the two algorithms are developed using machine learning techniques, and each one compared with evaluation metrics, ma'am, accuracy, precision, recall, confusion matrix, ma'am. So I conclude that I compared two types of algorithms with three categories of polymers, ma'am. That's all, ma'am. That's all, ma'am. Can you hear me, ma'am?
Thank you, ma'am. I'm having a question.
Okay,
You have
ma'am.
just normalized, isn't it? You have
Yes,
normalized.
ma'am.
What is the
Normalized.
length of the sequence you have fixed, or what is the length of the sequence fixed for normalization?
Ma'am, actually, I took that 150 sequences, ma'am. So in that, I give the formula min of x, ma'am. In that, x refers to the total number of sequences, ma'am. So I put the 150 to that value, ma'am. In here, in x, I put the 150 sequences, ma'am.
No,
So missing values
my question is, you'll be getting a normalization sequence, that is a sequencer, isn't it?
Yes, ma'am. Yes, ma'am.
After normalization, the length of the chosen polymer might have been decreased, or you would have fixed some normalized thing, isn't it? Uniform length of that. It won't be
Yes, ma'am.
always 150, isn't it? I'm asking the length what you have selected for the output.
Ma'am, totally normalization, I take training set in the test set, ma'am, 75, ma'am, out of 75, ma'am. Ma'am, can you hear me, ma'am?
Yes, yes. Thank you. Thank you.
Okay, thank you.
Thank you. The sixth presenter for the evening is OP33 HR Pradeep to present on the study on thin film dichromated gelatin coating methods for holography.
Hello, good evening, ma'am. Is my audible?
Good evening, sir. You can start.
Yeah.
Sir, you can start your
Just a
presentation.
minute, ma'am. As my topic is a study on thin film dichromated gelatin coating methods for holography. I am HR Pradeep, research scholar from Kongnadu Arts and Science College, Coimbatore, under the guidance of Dr. B. Chandrasekhar sir. The introduction of my topic: holographic light sensitive materials are DCG, silver halide, photopolymer, and photoresist. The DCG is a light sensitive material made from gelatin and a
You have to
small
concise
amount
your
of either
presentation
ammonium
to 3
dichromate
minutes.
or potassium dichromate.
Excuse me,
When the
sir.
laser light is exposed on the DCG film, the ordnance is creating
Excuse
a
me,
ordnance.
sir. You have to concise your presentation to 3 minutes, so you please go to the methodology of the presentation, sir.
Okay, ma'am. When laser light is exposed on the DCG film, the ordnance is creating a ordnance differentiation between exposed and unexposed regions. During the chemical process, exposed regions amplify and the unexposed regions are removed by bleachings and the washing process. Some advantages of the DCG: resolving power is higher than 5000 lines per mm. We can create in a single hologram. And the reprocessing ability in order to obtain an appropriate index modulation, high signal to noise ratio (SNR) and low absorption over the whole light range from the visible spectrum to near IR. Possible to record the transmission and reflection holograms in the same DCG material. The good long stability is the main advantage of this material, and the efficiency can be reached up to 100%. And the primarily it's UV to blue, green, and wavelength, but we can use by some appropriate dates. We can sensitize by the it will up to IR. And the coating types, there are spin coater, dip coater, gravity settlement, mold coating, Dr. Blade, and veil coating, and Mayer bar. These are the main coating methods we are using. Before the coating, we need to ensure the glass plate is must clean by 100%. If any dust particles or moisture anything on the surface, it will spoil the coating stiffness or easily peel off from the plate. So the cleaning method is the very important one. My objectives is emulsion coating with different methods: thickness and maintaining, surface quality, uniformity, low cost and easy availability, and handling. Spin coating. First one is the spin coating. The spin coater is thickness, uniformity, and the repeatability are the main advantage in the spin coating machine. And also the various thickness can be obtained by varying the DCG concentration and the spin coating rate. Due to the viscosity, the coating evenness is in the spin coating. Due to viscosity, the coating evenness is missing, and the plate edges are not covered properly during the spinning. The temperature and relative humidity (RH) are not are out of control. So the large size of plates cannot be coated in this spin coating, and the wastage is very high. The second one is dip coating. In this dip coating, dip coater machine is there. Dip coating refers to the immersing of the substrate into a tank containing DCG material, removing the piece from the tank and allowing it to dry. The coated piece can be dried by forced drying or baking or natural dye. It's a popular way to creating thin film coating materials. The drawback of this dip coating material, this process is very slow and it has the ability to block the screen, which will create major impact in the final product. The coating thickness varying between top and bottom. This small disadvantage in dip coating method. This is the dip coating machine. And next one is gravity settlement. This gravity settlement, zero alignment is most important. We need to ensure that the alignment of the table, it will be absolutely zero. First, we need to pour on the emulsion on the middle, the coating plate. Continuously pour emulsion once it overflow the coating plate. So it will be create a thin film coating, but some drawbacks: cannot reach specific thickness, uneven coating surface, not flatness, thinner layer cannot be made, and also thicker hologram can be made, but the emulsion trace is visible in the end of the result. The emulsion wastage. Next one is the mold coating. The mold coating is formed
So
on
you can conclude
Yeah,
your
okay.
already formed.
Yeah, this is a mold coating. This is the mold coating method, and also the veil coating. This one is the veil coating method is very important. Veil coating and Mayer bar are the best coating method in this DCG material. So our conclusion: Mayer bar and veil coating is the best material, best method to coat the DCG material. We have thickness up to 8 to 10 microns. We have half time, and the uniformity is good. Surface quality is excellent, and also easy handling, and also low cost. These are the coated emulsions. That's all, ma'am. Thank you.
Thank you, sir, for your nice
Thank you.
presentation. I'm just having one question. In what way the dichromated gelatin is superior to the usual silver halide used for holography?
What, ma'am?
In what way the dichromated gelatin is superior to the silver halide, which is normally used for holography?
Yeah, okay, ma'am. But this is this not only the silver halide you're adding. This is only for the dichromated gelatin. It's using ammonium dichromated or potassium dichromated, adding into the gelatin.
Thank you. Thank you, sir.
Okay, ma'am. Thank you. Thank you.
Thank you. The final presenter for the evening is OP47 M. Priyadarshana to present on comparative ethnomedico-botany of the Kanikas in Kerala, India, with Kanikas in some other areas of Tamil Nadu, India, a review. Kindly share your presentation and unmute your mic. OP47 M. Priyadarshana.
Am I audible, ma'am? Hello.
Yes, you are audible and the slides are visible. You can start.
Good evening, everyone. My topic is comparative ethnomedico-botany of the conifers in Kerala with the conifers in some other areas of Tamil Nadu. My aim of the study is, the specific objective of this study is to compare the traditional medicinal plants which are used for treating various human ailments by the conifers of Kerala with the conifers in other districts of Tamil Nadu. In previous publications, to know about the ailments treated and various parts used in the plants. Then let us know about the conifer. Conifer is one of the important tribe of Kerala and Tamil Nadu. They are basically a nomadic community. They live in Thiruvananthapuram, Kollam, Kanyakumari, Tirunelveli, and southernmost regions of India. Their main occupation is hunting, gathering, and shifting cultivation. In this study, the information of medicinal plants that are utilized by conifers in Tamil Nadu and Kerala are collected, and the common medicinal plants used by them were shortlisted. For this, I have chosen the publications which are having high medicinal, which are reported high medicinal plants through various electronic databases, Science Direct, ResearchGate, and Google Scholar. For this comparative study, I used a statistical method, Jaccard index. The Jaccard index is calculated by the formula C into 100 divided by A plus B minus C, where A is the number of plant species reported in the main paper, and B is the number of plant species reported in the compared paper, and C is the number of species common to both paper. These are the research papers which I have chosen for this comparative study. For when I compare the conifers of Kerala with conifers of Kautalai Hills, they both used three plants similar to treat different ailments, Hemidesmus indicus, Oxalis corniculata, and Veronia cinerea. The results of Conifers of Kerala with Conifers of Kalakkadu Muddandurai reveals that they both use 15 plant species to treat different human ailments, and these are the 15 plant species used commonly both of the Conifers. And the result of Conifers of Kerala with Conifers of Kanyakumari reveals that they both use 13 plant species as common to treat different human ailments. These are the 13 plant species used by them. Now I perform the Jaccard index. The results of the Jaccard index shows that the Conifers in Kanyakumari have a high similarity index with Kerala compared to Conifers of Kautalai and Conifers of Kalakkadu Muddandurai Reserve Forest. These are the results of the Jaccard index. Then coming to conclusion, by this comparative study, the potent medicinal plants among the tribal community and the medicinal plants with a multiple use can be known. Since the tribals have good ethnobotanical potential for traditional medicinal plants, they could be suitable for further comparative ethnobotanical studies and ethnopharmaceutical studies. Thank you so much. Thank you, ma'am.
Thank you, Priyadarshana.
Yes, ma'am.
It was a nice presentation. Thank you. One question is this. Thank you, Priyadarshana. Thank you.
Okay, ma'am.
Thank you. I thank all the presenters for your active participation. I also thank all the participants for patiently listening to us. With this, we have come to the end of the second day of International Interdisciplinary Virtual Conference on Breakthroughs and Approaches in Contemporary Scientific Research. Meet you all tomorrow by 11:15 a.m. Thank you. Everyone is now free to leave the meet.